71% of our planet lies beneath the waves, yet we've explored less than 5% of it. The ocean floor remains more mysterious to us than the surface of Mars. Down there, in the crushing darkness where sunlight has never touched, things exist that challenge everything we think we know about life, physics, and the very history of our world. Tonight, we're descending into that vast unknown together. Over the next 4 hours, we'll encounter sounds that have puzzled scientists for decades, creatures that shouldn't be able to survive where they do, and structures that seem to defy both time and explanation. We'll drift through bioluminescent gardens that pulse with alien light, explore abandoned ships that have become silent monuments to human ambition, and examine evidence of civilizations that may have thrived beneath the waves long before recorded history began. The deep ocean keeps its secrets well, but sometimes, just sometimes, it offers us glimpses of truths that are far stranger than any fiction we could imagine. Let the gentle rhythm of discovery carry you into sleep as we explore the mysteries that wait in the depths below. The Bloop sound anomaly. On July 4, 1997, a sound erupted from the depths of the Pacific Ocean that would haunt marine scientists for decades. The hydrophones of the National Oceanic and Atmospheric Administration captured something extraordinary that morning, a deep, prolonged rumble that traveled thousands of miles through the ocean's darkest channels. They called it the Bloop. The sound lasted approximately 1 minute, but its implications have stretched across 27 years of scientific debate. What emerged from those depths wasn't just noise, it was a mystery that challenged everything we thought we knew about the creatures lurking in our planet's most unexplored frontier. Dr. Asamuase of Dr. Christopher Fox was among the first scientists to analyze the recordings at NOAA's Pacific Marine Environmental Laboratory. When he first heard the digitally enhanced audio, his reaction was immediate and unsettling. The frequency pattern resembled biological origins, yet the sheer magnitude suggested something impossibly large, something that shouldn't exist. The Bloop originated from coordinates deep in the South Pacific, roughly 1,500 miles west of Chile's coast. This location places it in one of the most remote and unexplored regions of our oceans, where the seafloor plunges to depths exceeding 13,000 feet. The sound's ultra-low frequency allowed it to travel extraordinary distances through the ocean's oh-so-far channel, a natural acoustic waveguide that carries sounds across entire ocean basins. What made the Bloop truly extraordinary wasn't just its volume, but its acoustic signature. When marine biologists compared the sound to known whale calls, they found disturbing similarities. The frequency modulation, the tonal qualities, even the duration all suggested biological origins. Yet the intensity required an organism of unimaginable proportions. Blue whales, the largest known creatures on Earth, produce calls that register around 180 decibels. The Bloop measured significantly louder. For a biological source to generate such volume, the creature would need to dwarf even the largest blue whale by several orders of magnitude. We're talking about something potentially hundreds of feet long, moving through the deepest trenches of our oceans. Marine acoustics expert Dr. Robert Ziak spent years analyzing the Bloop's spectral characteristics. His findings revealed another puzzling dimension to the mystery. The sound exhibited what scientists call frequency dispersion. Different frequency components arrived at the hydrophones at slightly different times. This phenomenon occurs when sound waves interact with varying underwater topography and temperature gradients, suggesting the Bloop originated from extreme depths. The location itself adds another layer of intrigue. The coordinates place the Bloop's origin near the edge of the Antarctic circumpolar current, where massive underwater mountain ranges create complex acoustic environments. These seamounts and abyssal plains harbor ecosystems we've barely begun to explore. Less than 5% of our oceans have been directly observed by human eyes, and in these unmapped depths, the laws of biology might operate under entirely different parameters. Several theories emerged to explain the Bloop's origins. The biological hypothesis captured public imagination. Somewhere in the Pacific's deepest trenches, an unknown species of massive proportions had announced its presence to the world. Cryptozoologists immediately linked the discovery to legends of sea monsters and ancient leviathans, creatures described in maritime folklore across cultures and centuries. The geological explanation seemed more prosaic but equally mysterious. Could the bloop represent some form of underwater seismic activity? Perhaps the sound of massive ice shelves calving into the ocean, or tectonic plates shifting along the ocean floor. Yet seismic events typically produce different acoustic signatures, and the bloop's organic-sounding modulation didn't match known geological phenomena. Years later, NOAA scientists proposed that the bloop likely originated from Antarctic ice movements, massive icebergs cracking and shifting as they melted in the warming ocean. While this explanation addressed the volume and location, it failed to account for the sound's distinctly biological characteristics that had initially captivated researchers. But here's where the bloop becomes truly unsettling. Since 1997, similar sounds have been detected by underwater monitoring stations across the globe. The upsweep, the whistle, the slowdown, each with unique acoustic fingerprints, each defying complete explanation. These sounds suggest that whatever created the bloop wasn't an isolated incident, but part of a larger pattern of unknown oceanic phenomena. The deep ocean remains our planet's final frontier, more alien and unexplored than the surface of Mars. In the abyssal depths where the bloop originated, pressure exceeds 1,000 times that at sea level. No sunlight has ever penetrated these waters. The creatures that evolved in this environment faced evolutionary pressures we can barely comprehend, leading to adaptations that seem to defy natural law. Recent deep-sea expeditions have revealed organisms that challenge our understanding of biological limits: giant tube worms thriving around volcanic vents, bioluminescent creatures creating their own light sources, fish surviving at pressures that would instantly crush surface-dwelling organisms. If such creatures can exist in these extreme environments, what else might call the deep ocean home? The bloop's mystery deepens when we consider the timing of its detection. July 4, 1997, wasn't chosen by coincidence. That's simply when our limited monitoring capabilities happen to be listening. How many similar sounds occur in the vast stretches of ocean where no hydrophones exist? How many calls from the deep go unrecorded, unnoticed, unanswered? 27 years have passed since the bloop first echoed through scientific laboratories and research stations. Despite advances in underwater acoustics and deep-sea exploration, we remain no closer to definitively explaining its origins. The sound exists in that uncomfortable space between the known and unknown, between scientific explanation and enduring mystery. What lurks in the deepest trenches of our oceans continues to elude us. Whether the bloop represents the voice of an undiscovered species, the groaning of our planet's hidden geology, or something else entirely, it serves as a reminder that even on our own world, mysteries persist in the places we haven't yet learned to see. In the depths where the bloop was born, darkness reigns eternal, and the unknown still calls. The Mariana Trench Mystery. 7 miles beneath the Pacific surface, something extraordinary happened in 2019 that challenged everything marine biologists thought they knew about the limits of life on Earth. At a depth where the pressure would crush a human body in milliseconds, where no sunlight has penetrated for millions of years, researchers discovered not just life, but thriving communities of organisms that shouldn't exist according to our current understanding of biology. The Mariana Trench stretches like a wound across the ocean floor, deeper than Mount Everest is tall. For decades, scientists assumed this alien landscape was largely barren, perhaps home to a few hardy microbes clinging to existence in one of the most hostile environments our planet offers. The pressure down there exceeds 1,000 times what we experience at sea level. The temperature hovers just above freezing. There's no light, no photosynthesis, no foundation for the food webs we understand. Yet when the deep-sea submersible limiting factor descended to Challenger Deep, the trench's lowest point, it captured footage that left researchers speechless. Xenophyophores, single-celled organisms the size of softballs, carpeted sections of the seafloor like alien flowers. These mysterious creatures, among the largest single-celled life forms on Earth, seemed to be thriving in conditions that would sterilize most environments. But their presence raised unsettling questions. How do they process energy without sunlight? What do they consume in this apparent wasteland? And perhaps most intriguingly, how long have they been down there, evolving in complete isolation from the surface world? The more scientists studied these deepest reaches, the more perplexing the discoveries became. In 2021, researchers found evidence of what appeared to be complex chemical processes occurring around hydrothermal vents scattered throughout the trench. These underwater hot springs, spewing mineral-rich water at temperatures exceeding 400 degrees Celsius, seem to support entire ecosystems based on chemosynthesis rather than photosynthesis. But here's where the mystery deepens. The organisms found near these vents weren't just surviving, they were displaying behaviors that suggested sophisticated adaptation mechanisms. Tube worms measuring several feet in length had developed symbiotic relationships with bacteria that could process hydrogen sulfide, a compound lethal to most life forms. These partnerships appeared to be so refined, so perfectly calibrated, that some researchers began questioning whether they were witnessing millions of years of evolution or something else entirely. Dr. Patricia Fryer, a marine geologist who has spent her career studying the Mariana region, made an observation that sent ripples through the scientific community. The rate of evolution she was witnessing in these deep-sea organisms seemed to be accelerating. Genetic analysis of specimens collected years apart showed variations that should have taken millennia to develop, happening instead across mere decades. Then came the discovery that truly challenged conventional understanding. In 2022, researchers found what appeared to be organized structures on the trench floor, geometric patterns that seemed too regular to be natural formations. These weren't the random scatterings of geological processes, but arrangements that suggested purpose. The structures, composed of what appeared to be secreted materials from the xenophyophores, formed intricate networks spanning hundreds of meters. Some researchers theorized they might be feeding systems, ways for these massive single-celled organisms to maximize their exposure to nutrients drifting down from the surface world miles above. Others suggested they might serve as protection against the crushing currents that occasionally sweep through the trench's deepest channels. But a growing number of marine biologists began proposing a more radical theory. What if these organisms weren't just surviving in isolation, but actually communicating? What if the Mariana Trench harbored not just life, but intelligent life, operating on timescales and through mechanisms we're only beginning to comprehend? The evidence, while circumstantial, was compelling. Chemical signals detected in the water around these formations suggested complex molecular exchanges. The patterns of growth and organization implied coordination between organisms separated by vast distances in the eternal darkness. Most intriguingly, the timing of certain activities seemed to correlate with tidal cycles and seismic events, suggesting these deep-sea communities might be far more aware of the surface world than anyone had imagined. Recent advances in deep-sea exploration technology have revealed another layer to this mystery. High-resolution sonar mapping has identified what appear to be vast cavern systems within the trench walls themselves, spaces that could harbor entire ecosystems yet to be explored. Some of these caverns extend for miles, creating three-dimensional habitats that might support levels of biodiversity rivaling tropical rainforests. The implications extend far beyond marine biology. Astrobiologists studying the potential for life on other worlds have begun looking to the Mariana Trench as a laboratory for understanding how life might exist in the subsurface oceans of Jupiter's moon Europa or Saturn's Enceladus. The organisms thriving in the trench's extreme conditions might represent our best analog for alien life, creatures that have evolved independently of solar energy, operating through biochemical processes we're still struggling to understand. Yet for every answer the trench provides, it raises 10 new questions. Recent expeditions have detected acoustic anomalies, sounds that don't match any known geological processes or marine life. These low-frequency vibrations seem to propagate through the trench system in ways that suggest they might be serving some kind of communication function. The Mariana Trench keeps its secrets well. Each expedition brings back evidence of phenomena that expand our understanding of what's possible in Earth's most extreme environments, while simultaneously revealing how much we still don't know about the world beneath our feet. In those crushing depths, where pressure and darkness reign supreme, life has found ways to not just endure, but to flourish in forms so alien they challenge our very definitions of existence. Perhaps the most humbling realization is that we've explored less than 5% of our ocean's depths. If the small fraction of the Mariana Trench we've managed to study harbors such mysteries, what discoveries await in the vast unexplored reaches of the deep sea? Colossal squid observations. In 2007, New Zealand fishermen hauling their lines from the Ross Sea felt their nets strain against something extraordinary. What emerged from those Antarctic waters wasn't just another catch, it was a creature so massive, so alien, that marine biologists questioned whether they were looking at an animal or something from another world entirely. The colossal squid they pulled from the depths measured over 30 feet in length and weighed nearly half a ton. But here's what stopped the scientific community cold. This wasn't even a fully grown adult. For centuries, sailors spoke of sea monsters with eyes the size of dinner plates and tentacles that could crush ships. We dismissed these as folklore, the fevered imaginings of men too long at sea. Yet as this frozen behemoth lay on that New Zealand dock, researchers stared into eyes larger than any animal on Earth, eyes that had evolved specifically to see in the absolute darkness of the deepest ocean trenches. The colossal squid, Mesonicotithis hamiltoni, exists in a realm so remote that we know more about the surface of Mars than we do about their hunting grounds. These creatures inhabit the Antarctic waters at depths where sunlight has never penetrated, where the pressure would crush human bones like glass, where the temperature hovers just above freezing. But what we've discovered about them challenges everything we thought we knew about life in the deep ocean. Their eyes, measuring up to 11 inches across, aren't just large for show, they're precision instruments, evolved over millions of years to detect the faintest traces of bioluminescence in the midnight depths. Think about that for a moment. In a world of complete darkness, these creatures developed the most sophisticated visual system on our planet. What are they watching for down there? The few specimens we've recovered reveal anatomy that seems designed for warfare. Their tentacles don't just have suckers, they're armed with rotating hooks, sharp as surgical blades, that can extend and retract like switchblades. These aren't the tentacles of a filter feeder or passive hunter. These are the weapons of an apex predator built to take on prey we can barely imagine. Marine biologist Dr. Steve O'Shea, who has spent decades studying deep-sea cephalopods, made an observation that haunts the scientific community. The colossal squids they've examined show scars, deep, parallel gouges across their mantles that could only come from one source: the teeth of sperm whales. But here's where it gets unsettling. The whales bear scars too, circular marks, some over 18 inches across, left by suckers and hooks. These aren't the marks of prey, they're the wounds of combatants, battles between titans playing out in the absolute darkness, 2 miles beneath our feet, with neither creature guaranteed to survive the encounter. In 2003, researchers tracking a sperm whale pod in the Southern Ocean detected something through their hydrophones that made them question their equipment. The sounds weren't whale songs, they were something else entirely. Low-frequency clicks and pulses, unlike anything in their acoustic databases. When they triangulated the source, it was coming from directly below the whales, at depths exceeding 6,000 feet. Dr. Mark Norman, a cephalopod expert at the Museum Victoria, believes these may have been the hunting calls of colossal squids. But if that's true, it suggests something remarkable and deeply unsettling. These creatures aren't just solitary hunters. They might be coordinating, communicating across the vast darkness of the deep ocean in ways we're only beginning to detect. The colossal squid's beak, discovered in the stomachs of captured specimens, measures larger than a human fist. It's made of a protein harder than most metals, designed to crush through the toughest armor nature can produce. But forensic analysis of these beaks reveals something peculiar. They show wear patterns consistent with prey, much larger than anything we know exists at those depths. What are they feeding on down there? Temperature readings from the depths where colossal squids hunt show anomalies that marine climatologists can't fully explain. Pockets of water several degrees warmer than the surrounding ocean, without any apparent geological source. Some researchers theorize these might be feeding grounds, heated by the metabolic activity of massive deep-sea organisms we haven't discovered yet. The colossal squid's mantle contains photophores, light-producing organs that can create patterns of bioluminescence across their body. In most deep-sea creatures, these serve as camouflage or mating displays, but the colossal squid's photophores are different. They're larger, more complex, arranged in configurations that suggest something more sophisticated than simple communication. Dr. Edith Witter, who pioneered deep-sea bioluminescence research, captured footage of what appeared to be coordinated light displays between multiple large cephalopods in the Antarctic depths. The patterns were too complex, too purposeful to be random. They looked almost linguistic. When the 2007 specimen was thawed and examined, researchers made a discovery that sent ripples through the marine biology community. Preserved in the creature's stomach were the partially digested remains of fish species that weren't supposed to exist at those depths. Deep-sea fish with anatomical features that didn't match any known species in the taxonomic record. The implications were staggering. Either our understanding of deep ocean ecosystems is fundamentally incomplete, or colossal squids are traveling to depths and regions we never imagined possible, encountering life forms that remain hidden from human observation. But perhaps the most disturbing discovery came from genetic analysis of the specimen's tissue. The colossal squid's DNA contains sequences that don't match any known cephalopod lineage. Sections of their genetic code appear to be millions of years older than any other known squid species, as if they represent an ancient branch of evolution that continued developing in isolation, far beneath the surface world. Recent deep-sea surveys using advanced sonar have detected massive objects moving through the Antarctic depths, objects too large and too organized in their movement to be geological features, yet too deep to be whales. When researchers attempted to get closer with submersibles, the objects vanished into the abyssal trenches, leaving only the faint trace of bioluminescent trails in the water. The colossal squid specimens we've recovered might not be the true giants of the deep. They might just be the juveniles that venture close enough to the surface to encounter human fishing operations. The real titans, the fully mature adults, may dwell in trenches so deep and remote that they remain completely beyond our reach, growing to sizes that would dwarf our largest ships. In the perpetual darkness of the deep Antarctic waters, something vast and intelligent moves through the crushing depths, watching our surface world with eyes larger than any creature should possess, hunting prey we've never seen, communicating in languages of light we're only beginning to recognize. The ocean keeps its deepest secrets well. The underwater Yonaguni Monument, 25 meters beneath the surface, where the Pacific Ocean meets the southern shores of Japan, lies a structure that has fractured the archaeological community for over 3 decades. The Yonaguni Monument stands in defiant silence, its geometric precision challenging everything we thought we knew about human civilization's timeline. In 1987, dive tour operator Kihachiro Aratake was searching for new diving spots when he encountered something that shouldn't exist. Massive stone terraces descended into the depths, carved with right angles so sharp they seemed to slice through the water itself. Steps led nowhere and everywhere. Corridors opened into chambers that had known only darkness for millennia. What Aratake had stumbled upon would become Japan's most contentious underwater mystery. The Yonaguni Monument, stretching 150 meters long and rising 25 meters from the seafloor, presents a puzzle that pits geology against archaeology, nature against human ingenuity. Marine geologist Masaki Kimura spent decades studying these formations, diving hundreds of times to document every angle, every carved edge. His conclusion shattered conventional timelines. These weren't natural formations, he argued, but the remnants of a 12,000-year-old civilization. If true, this would mean advanced stoneworking existed in Japan when most of human society was still learning to farm. The implications ripple outward like waves from a dropped stone. 12,000 years ago, these formations would have stood on dry land before the last ice age ended and sea levels rose to claim them. This timing aligns with global flood myths, with stories passed down through generations about great cities swallowed by rising waters. But geology rarely yields to romance. Robert Schoch, the Boston University geologist, who dared to suggest the Sphinx might be older than accepted, examined Yonaguni with the same methodical skepticism. His assessment? Nature, not human hands, carved these underwater monuments. The Pacific's relentless currents and seismic activity, he argued, could explain the geometric precision that has captivated so many. Yet doubt lingers in the details. How does natural erosion create perfect 90-degree angles? What geological process carves steps with such uniform spacing? The monument's main structure features what appears to be a massive platform, complete with what look like roads, staircases, and even ceremonial areas. One formation has been dubbed the Turtle, another the Stadium, for their uncanny resemblance to human constructions. Local Okinawan folklore adds another layer to the mystery. For generations, islanders have spoken of Mu, a lost Pacific civilization that sank beneath the waves. These stories, dismissed as myth by mainstream academia, suddenly seem less fantastical when divers swim through stone corridors that may have once echoed with human voices. The monument's orientation adds to the intrigue. The main structure aligns with cardinal directions with mathematical precision. Its terraced levels create natural amphitheaters, spaces that would have been perfect for gatherings or ceremonies. Tool marks, invisible to natural weathering, score certain surfaces, suggesting deliberate human modification. Temperature readings from the monument's depths reveal anomalies that complicate both natural and artificial theories. The stone retains heat differently than surrounding formations, creating thermal signatures that don't match known geological patterns. These readings suggest internal structures, possibly chambers or passages that remain unexplored. Photography from different angles reveals the monument's true scale and complexity. From above, the formation resembles a step pyramid, its terraced sides creating shadows that shift throughout the day. From the side, massive blocks appear fitted together with construction techniques that wouldn't look out of place in ancient Egypt or Peru. The debate has spawned expeditions, documentary films, and academic papers arguing both sides. Each dive reveals new details that support conflicting theories. Natural formations don't typically include the sharp corners and flat surfaces found throughout Yonaguni, yet the rock's sandstone composition is known for creating unusual erosion patterns. Carbon dating of marine organisms growing on the monument provides only approximate timelines. The creatures themselves are relatively recent, but the surfaces they've colonized could be far older. Without organic material from the original construction, precise dating remains impossible. Japan's archaeological establishment has largely dismissed the monument as a natural formation, but this official position hasn't stopped independent researchers from making startling discoveries. Stone tools, pottery fragments, and what appear to be carved symbols have been found in surrounding areas, though their connection to the monument remains disputed. The sea level question haunts every discussion. If human-made, Yonaguni was constructed when this area was dry land, before post-glacial flooding transformed the landscape. This timeline places its construction during a period when conventional archaeology suggests Japan was inhabited by hunter-gatherer societies with no stoneworking traditions. Modern sonar mapping has revealed additional structures in the surrounding area, formations that follow similar geometric patterns. These secondary sites suggest Yonaguni might not be an isolated anomaly but part of a larger complex, now scattered across the ocean floor. The monument's preservation raises its own questions. Underwater environments typically accelerate erosion, yet Yonaguni's sharp edges and defined surfaces remain remarkably intact. This preservation suggests either recent exposure or protection by unique environmental conditions. Local diving guides report strange acoustic properties within the monument's chambers. Sounds carry differently here, creating echoes that don't match the open ocean environment. These acoustic anomalies might result from the structure's internal geometry, whether natural or artificial. The Yonaguni monument continues to guard its secrets, 25 meters below the surface, where human interpretation meets geological reality. Each dive expedition returns with more questions than answers, more evidence for both sides of an argument that may never be resolved. In the end, perhaps the monument's greatest mystery isn't whether it's natural or human-made, but why it matters so much to us. In its terraced silence, we see either the power of nature to create the impossible, or evidence that human civilization reaches far deeper into the past than we ever imagined. The Pacific keeps its counsel, and the monument waits, patient as stone, for the next diver to descend in wonder. Bioluminescent ocean phenomena. 73% of all marine species produce their own light. When marine biologist Dr. Edith Witter first descended into the midnight zone in 1984, she expected darkness. What she found instead was a living constellation that defied every assumption about life in the deep. The ocean's bioluminescent displays aren't random sparkles of beauty. Their communications were only beginning to decode. Each flash, each ripple of blue-green light carries information across vast underwater distances. The deeper we go, the more intricate these light shows become, until the very concept of darkness dissolves into something far more complex. Consider the vampire squid, suspended 2,000 feet below the surface. When threatened, it doesn't flee or attack. Instead, it erupts in a cascade of bioluminescent mucus, creating a cloud of living light that confuses predators while the squid vanishes into the depths. This isn't mere survival, it's sophisticated chemical engineering that puts our best fireworks to shame. The mechanism itself borders on the impossible. Luciferin, a compound that exists in hundreds of different forms across marine species, reacts with the enzyme luciferase to produce light with 96% efficiency. Our most advanced LED technology struggles to reach 20%. These creatures have spent millions of years perfecting what we can barely comprehend, transforming chemical energy into pure illumination without generating heat. But the real mystery lies in coordination. In 1996, researchers documented something unprecedented in Monterey Bay. Hundreds of deep-sea species, spanning multiple taxonomic groups, began producing synchronized light displays across a 12-mile stretch of ocean floor. The phenomenon lasted for 6 hours, then ceased as suddenly as it had begun. No environmental trigger could explain it. No predator threat justified such widespread response. The patterns themselves defy conventional understanding of marine behavior. Atoll jellyfish create what researchers call the burglar alarm, a spinning wheel of light that can be seen from over a mile away. When attacked, they sacrifice their own concealment to broadcast their distress, apparently hoping to attract an even larger predator that might consume their attacker. It's a desperate gamble that requires the jellyfish to understand complex food chain dynamics. Dr. Witter's team has documented over 40 distinct bioluminescent languages in the deep ocean. Each species seems to operate on its own frequency, its own rhythm of communication. But occasionally, these languages intersect in ways that suggest something far more organized than random biological processes. The geographic distribution raises additional questions. Bioluminescence reaches its peak intensity in the deep ocean's most isolated regions, places where no sunlight has penetrated for millions of years. These environments should favor energy conservation, not the metabolically expensive production of light. Yet here, creatures invest enormous resources in creating displays that rival any earthly aurora. Recent discoveries have complicated our understanding even further. In 2018, marine biologists identified bioluminescent bacteria living inside the shells of deep-sea mollusks. These bacteria don't harm their hosts, they appear to enhance them, creating hybrid organisms that combine the mollusk's mobility with the bacteria's light-producing capabilities. The relationship suggests evolutionary partnerships that developed over vast periods of time, possibly predating the emergence of complex life on land. The temporal patterns are equally puzzling. Bioluminescent displays in the deep ocean follow 24-hour cycles, even at depths where no trace of sunlight exists. These creatures maintain circadian rhythms in perpetual darkness, somehow synchronized with the distant surface world. Some species exhibit monthly cycles that correspond to lunar phases, despite living miles beneath the moon's direct influence. The intensity of these displays varies dramatically, with ocean temperature and current patterns. Climate researchers have noticed that bioluminescent activity increases during periods of unusual deep-water circulation. The connection between global climate systems and deep-sea light production opens questions about sensitivity and communication networks we've never considered. Perhaps most intriguingly, bioluminescent species appear to respond to human presence in ways that suggest awareness beyond typical marine behavior. Submersible pilots report that bioluminescent displays often intensify when deep-sea vessels approach, creating what appears to be welcoming or warning signals. The lights seem to track the movement of research vehicles, maintaining distance while following their paths through the water. These observations challenge our fundamental assumptions about consciousness and communication in the deep ocean. If bioluminescent organisms can recognize and respond to artificial objects, what does this suggest about their cognitive capabilities? The traditional view of deep-sea life as primitive and instinct-driven becomes increasingly difficult to maintain when faced with such sophisticated light-based communications. The chemical complexity of bioluminescence varies dramatically between species, suggesting multiple evolutionary pathways toward the same result. Some creatures produce light through single-celled organisms living in specialized organs. Others generate illumination through complex protein interactions that require precise timing and environmental conditions. The diversity of approaches indicates that bioluminescence has evolved independently countless times, each species developing its own solution to the challenge of deep-sea communication. Modern research vessels equipped with sensitive light detection equipment have revealed that bioluminescent displays extend far beyond the visible spectrum. Many deep-sea species produce infrared and ultraviolet emissions that remain invisible to human observers. These hidden light shows suggest communication networks operating on frequencies we're only beginning to detect. The implications reach beyond marine biology. If life in Earth's most isolated environments can create such sophisticated systems of communication and cooperation, what does this suggest about the possibility of similar phenomena elsewhere? The deep ocean may be providing us with a template for understanding how life might develop in the isolated dark environments that exist throughout the universe. Each descent into the bioluminescent depths reveals new questions about the nature of consciousness, communication, and cooperation in environments that seemed too hostile for such complex behaviors. The ocean's living light shows continue to challenge our understanding of what life can accomplish in the planet's most mysterious spaces. Baltic Sea Anomaly. Beneath the dark waters of the Baltic Sea, 60 meters down, lies something that shouldn't exist. When Swedish treasure hunters Peter Lindberg and Dennis Osberg first spotted it on their sonar in June 2011, they were searching for shipwrecks and lost cargo. Instead, they found an object that has left experts scrambling for explanations ever since. The formation measures roughly 60 meters in diameter, about the size of a jumbo jet, but its geometry defies easy categorization. Sonar images reveal what appears to be a circular structure with straight edges, angular formations, and what some describe as a ramp or staircase leading up to it. Most unsettling of all, the object seems to have carved a distinct trail behind it, as if it had been dragged across the seafloor before coming to rest. When the Ocean X team first released their sonar data, the internet exploded with theories. The object's disc-like appearance and unusual geometry immediately drew comparisons to something from science fiction. But as diving expeditions began and more data emerged, the mystery only deepened. The first dive team to reach the anomaly reported technical difficulties that seemed to follow no logical pattern. Electronic equipment malfunctioned, satellite phones lost their signals, camera systems failed. According to the divers, anything electronic stopped working within a 200-meter radius of the object. The moment they moved away, their equipment mysteriously resumed normal function. Stefan Hogeborn, one of the professional divers who examined the structure firsthand, described the surface as unlike anything he'd encountered in decades of underwater exploration. "It's not a normal stone," he said. The formation appeared to be covered in a thin layer of sediment, but beneath that, the material had an almost metallic quality. Sections showed what looked like perfectly straight edges and right angles, geometries that natural rock formations rarely, if ever, produce. The samples that were successfully retrieved and analyzed revealed something curious. The object contained metals and materials that, while not impossible to find in nature, occurred in combinations that raised questions. Some sections showed evidence of extreme heat exposure, as if the object had been subjected to temperatures that shouldn't exist naturally at the bottom of the Baltic Sea. Geologist Steve Weiner from the Weizmann Institute of Science examined the samples and noted the presence of limonite and goethite iron oxides that can form naturally, but in this case appeared in patterns that suggested rapid formation under intense heat. "It's as if something burned very hot and then cooled rapidly," he observed, though he couldn't explain what might have caused such conditions on the seafloor. The theories surrounding the Baltic Sea anomaly range from the plausible to the extraordinary. Some researchers suggest it could be a glacial formation, a massive boulder dropped by retreating ice sheets thousands of years ago. The drag marks behind it could theoretically be explained by underwater currents slowly pushing the object across the seafloor over centuries. Others point to the region's wartime history. The Baltic Sea was a theater of intense naval combat during World War II, and numerous experimental weapons were tested in its waters. Some theorists propose the object could be remnants of a secret Nazi weapon, perhaps a prototype submarine or experimental craft that was scuttled in the closing days of the war. The metallic composition and apparent heat damage could support this theory, but the electronic interference phenomenon has proven difficult to explain through conventional means. Dr. Volker Bruckert, an associate professor of geology at Stockholm University, was brought in to study the anomaly. While he remained skeptical of more exotic explanations, he admitted that the electronic failures reported by multiple independent diving teams were unusual and worth investigating. The shape itself continues to baffle researchers. Natural geological processes rarely produce the kind of perfect circles and angular formations seen in the sonar data. Even more puzzling, subsequent sonar sweeps of the area have shown what appear to be smaller, similar objects scattered around the main formation, as if they were once part of a larger whole. What makes the Baltic Sea anomaly particularly intriguing is how it doesn't quite fit any single explanation. It's too geometric to be easily dismissed as a natural formation, yet too old and weathered to be recent human technology. The electronic interference suggests properties that current science struggles to explain, while the materials analysis provides just enough conventional data to keep the mystery alive. OceanX team member Dennis Osberg has spent over a decade studying the object, and his perspective has evolved considerably. Initially, I was convinced we'd find a simple explanation, he admits, but every answer we've found has led to 3 more questions. The more we learn about this thing, the less sense it makes. The Baltic Sea itself holds many secrets. Its waters preserve artifacts remarkably well due to low salinity and cold temperatures. Wooden ships from the 1600s remain intact on its bottom, their details preserved as if they sank yesterday. But the anomaly seems to exist outside this natural museum of maritime history. Recent expeditions have focused on mapping the surrounding seafloor in greater detail. These surveys have revealed what appear to be additional anomalies in the region, smaller formations with similar characteristics scattered across a wider area. Whether these are related to the main object or represent separate phenomena remains unclear. The story of the Baltic Sea anomaly reflects larger questions about what we truly know about our planet's hidden places. In an age where we've mapped the surface of Mars with incredible precision, vast areas of our own ocean floors remain complete mysteries. The Baltic Sea, despite being one of the most studied bodies of water on Earth, continues to yield discoveries that challenge our understanding. As research continues, the anomaly remains exactly what it was when first discovered, an unexplained presence resting quietly on the sea floor, waiting for the right questions to unlock its secrets. Whether it represents a natural phenomenon we don't yet understand, a relic of forgotten history, or something else entirely, the Baltic Sea anomaly serves as a reminder that mystery still exists in our world, lying patiently beneath 60 meters of dark water. The ghost ships of the Bermuda Triangle. When Captain John Mitchell radioed the Coast Guard on March 15, 2019, his voice carried the kind of confusion that comes from witnessing something that shouldn't exist. He'd spotted a cargo vessel drifting 3 miles southeast of his fishing boat, moving against the current with no visible crew on deck. What made his report unusual wasn't the abandoned ship, it was that the same vessel had been reported sunk 47 years earlier. The waters of the Bermuda Triangle have collected more than their share of maritime mysteries, but none quite as persistent as the phenomenon of ghost ships. These aren't the romanticized phantoms of sailor folklore. They're documented encounters with vessels that continue to navigate waters long after their crews have vanished, defying both maritime physics and rational explanation. The SS Orang Medan remains perhaps the most disturbing case. In July 1947, multiple ships received distress calls from the Dutch freighter, reporting the death of the entire crew. When rescue vessels arrived, they found the ship intact, but every soul aboard dead, their faces frozen in expressions of absolute terror. Before investigators could determine the cause, the ship exploded and sank. Yet maritime records from the following decade contain 17 separate sightings of a vessel matching the Orang Medan's exact specifications, always unmanned, always moving purposefully through shipping lanes. What challenges conventional understanding is the consistency of these reports. Coast Guard archives contain over 200 documented encounters with apparently crewless vessels in Triangle waters since 1950. These aren't distant glimpses or weather-distorted mirages. Modern radar systems track these ships for hours. Helicopters circle them, capturing clear footage of empty decks and dark wheelhouses. Radio attempts go unanswered, yet the vessels maintain steady courses and respond to navigational hazards as if someone were at the helm. The MV Joyhita case demonstrates how these encounters blur the line between disappearance and reappearance. The merchant vessel vanished with 39 passengers and crew in 1955. 5 weeks later, searchers found the ship partially submerged but still afloat, with no trace of human life. The official investigation concluded that the passengers and crew had abandoned ship due to structural failure. But that explanation faltered when multiple commercial vessels reported sightings of the fully intact Joyhita throughout the 1960s, apparently seaworthy and underway. Dr. Bang, Elena Vasquez, who spent 12 years studying unexplained maritime phenomena for the Naval Research Laboratory, documented something even more perplexing. Her team tracked what appeared to be the same fishing vessel over a 6-month period in 2003. Radar signatures matched perfectly across 14 separate encounters by different ships. Each time, the vessel appeared to be following established fishing patterns, yet boarding attempts found empty holds and no signs of recent human activity. The environmental factors of the triangle itself may contribute to these mysteries. The region sits atop several underwater methane deposits, which occasionally release massive gas bubbles to the surface. These eruptions can alter water density so dramatically that ships lose buoyancy instantly, potentially explaining some disappearances. But they don't explain reappearances. Ocean currents in the area follow complex patterns influenced by the Gulf Stream, Caribbean Current, and Antilles Current. These forces can carry debris for thousands of miles, occasionally depositing wreckage in the same waters where ships originally vanished. Dr. Vasquez theorized that some ghost ship sightings might actually be partially submerged hulks that surface and submerge based on tidal forces and gas releases from the ocean floor. The psychological component cannot be dismissed. Professional mariners spend long periods in isolation, surrounded by endless water. The brain, seeking patterns and familiarity, sometimes constructs detailed hallucinations from distant objects, unusual cloud formations, or the interplay of light and shadow on waves. Multiple witnesses reporting the same sighting could represent collective suggestion rather than objective reality. Yet this psychological explanation struggles against the physical evidence. In 1987, the cargo ship Aztec Princess encountered what appeared to be a World War II-era destroyer at dawn, roughly 30 miles southwest of Bermuda. Captain Robert Shaw not only observed the vessel through binoculars for nearly an hour, but recorded its progress on radar. His logbook notes that the destroyer maintained a steady heading, despite heavy swells that should have required constant course corrections. When Shaw attempted to approach, the vessel simply wasn't there anymore. Radar showed empty ocean. Modern technology has added new dimensions to these encounters. GPS tracking, satellite imagery, and advanced radar systems create multiple verification points for ship positions and movements. When the research vessel Deep Explorer reported following an unmanned yacht for 3 hours in 2015, satellite data confirmed the yacht's presence and trajectory. Coast Guard vessels dispatched to investigate found nothing, but the satellite record remained unchanged. The quantum physics community has proposed theories involving temporal displacement. Some scientists suggest that the unique electromagnetic properties of the Triangle region might create conditions where past events briefly intersect with present reality. Under this hypothesis, ghost ships wouldn't be supernatural phenomena, but rather electromagnetic echoes of historical maritime activity. Dr. Marcus Webb, a theoretical physicist at Johns Hopkins, spent 2 years analyzing electromagnetic readings from the Triangle region. His research identified unusual magnetic field fluctuations that correspond roughly with ghost ship sighting patterns. These magnetic anomalies could theoretically affect both navigation equipment and human perception, creating shared hallucinations or even brief tears in space-time continuity. The most unsettling aspect of ghost ship encounters isn't their appearance, it's their apparent intelligence. These vessels don't drift aimlessly. They maintain courses, avoid collisions, and sometimes seem to respond to other ships in their vicinity. In 1993, Multiple witnesses reported watching an unmanned trawler change course to avoid a collision with a Coast Guard cutter. The maneuver required precise timing and clear awareness of both vessels' positions and speeds. Whatever forces govern these ghostly appearances continue to operate in triangle waters. As recently as 2021, commercial satellite imagery captured what appeared to be a 19th-century sailing ship moving through modern shipping lanes near Nassau. The image quality was exceptional, showing clear detail of masts and rigging, but no human figures anywhere on deck. The ocean keeps its secrets well, and in the depths beneath the triangle, some mysteries may be destined to remain unsolved. The Gulf of Mexico's brine pools. 3,000 feet beneath the surface of the Gulf of Mexico, marine geologist Dr. Eric Cordes encountered something that challenged his understanding of what was possible underwater. Through the porthole of his submersible, he watched as his vehicle approached what appeared to be a perfect shoreline beneath the ocean itself. The year was 2007, and Cordes was leading a deep-sea expedition when his team stumbled upon these underwater lakes, bodies of supersaturated brine, so dense they formed distinct boundaries with the seawater above. But these weren't just scientific curiosities. They were environments so alien that NASA would later study them as analogs for potential extraterrestrial oceans. The Gulf of Mexico harbors dozens of these brine pools, each one a liquid boundary between worlds. The largest, dubbed the Jacuzzi of Despair by researchers, spans nearly 100 feet across and sits in perfect stillness, its surface reflecting the submersible's lights like a mirror in an underwater cathedral. What creates these impossible lakes stems from ancient geological processes. Millions of years ago, when the Gulf of Mexico was a shallow sea, massive salt deposits formed through repeated cycles of flooding and evaporation. Over time, these salt domes became buried under layers of sediment and rock. When oil and gas extraction began disturbing these formations, or when natural seepage occurred, the ancient salt dissolved into the surrounding water, creating brine so dense up to 5 times saltier than regular seawater that it cannot mix with the ocean above. Yet the physics alone don't capture the strangeness of encountering these pools. Eric Cordes described the experience as otherworldly. You're flying along in this submersible, and suddenly there's a shoreline ahead of you. There are waves lapping at the edges. There's a distinct boundary between 2 different bodies of water, and you're already underwater. The brine pools maintain their own distinct ecosystems, though ecosystem might be too generous a term. The extreme salinity and hydrogen sulfide concentrations create conditions toxic to most marine life. Fish that venture too close become disoriented, their nervous systems compromised by the chemical composition. Many don't survive the encounter, their bodies settling along the pool's perimeter like victims of an underwater gas chamber. But life, as it tends to do, finds ways to persist even in these hostile environments. Along the shorelines of these brine lakes, researchers discovered thriving communities of tube worms, some growing 6 feet long and living for centuries. These creatures have formed symbiotic relationships with bacteria that can process the toxic hydrogen sulfide, essentially eating poison and converting it into energy. The bacterial mats themselves create landscapes that seem borrowed from another planet. They form thick, colorful carpets along the brine pool edges, sometimes white, sometimes orange, sometimes deep purple depending on the specific chemical processes occurring. Under the submersible's lights, these bacterial communities shimmer and flow like living paintings. Dr. Lisa Levin, a marine biologist who has studied these formations extensively, noted something particularly unsettling about the brine pool's behavior. Their surfaces aren't perfectly still. They respond to deep ocean currents and temperature changes, creating wave patterns that mirror those found on terrestrial lakes. Sometimes, the waves are large enough to splash over the pool's edges, creating underwater cascades of supersaturated brine. This wave activity has led to one of the most intriguing aspects of brine pool research. The pools appear to have their own weather systems. Temperature variations between the brine and surrounding seawater create convection patterns. Chemical gradients establish their own current systems. In essence, these underwater lakes operate by their own meteorological rules, independent of the ocean that contains them. NASA's interest in the Gulf of Mexico's brine pools extends beyond mere scientific curiosity. Jupiter's moon Europa, and Saturn's moon Enceladus, both harbor subsurface oceans beneath their icy shells. These alien seas likely contain varying salinity levels and chemical compositions that could create similar stratified environments. By studying how life adapts to the extreme conditions in Earth's brine pools, researchers hope to understand what signs of life to look for in extraterrestrial oceans. The chemical signatures found around these pools, specific combinations of methane, hydrogen sulfide, and various minerals, might serve as biosignatures detectable by future space missions. If similar chemical fingerprints exist around stratified pools in Europa's ocean, they could indicate active biological processes occurring in an alien sea. But perhaps the most profound mystery surrounding the brine pools isn't biological or geological, it's sensory. Multiple researchers have reported an almost supernatural quality to encountering these formations. The absolute silence that surrounds them creates an acoustic void unlike anywhere else in the ocean. Sound waves behave differently at the density boundary between brine and seawater, creating acoustic mirages and dead zones. Dr. Samantha Joy, who has spent decades studying Gulf of Mexico deep sea environments, described her first brine pool encounter as like discovering a hidden room in a house you thought you knew completely. The psychological impact of finding lakes within the ocean challenges fundamental perceptions about the nature of our planet's waters. Recent technological advances have revealed that these pools are far more dynamic than originally understood. Time-lapse photography shows them expanding and contracting over seasonal cycles. Some pools merge with others, creating underwater river systems of supersaturated brine flowing between basins. Others disappear entirely, their contents dispersed by changing current patterns, only to reform years later as geological processes continue their ancient work. The Gulf of Mexico's brine pools remain active research sites, their alien characteristics serving as natural laboratories for understanding extreme life and potential astrobiology. Each dive reveals new aspects of their behavior, new species adapted to their toxic embrace, and new questions about how life persists in environments that should, by most measures, be uninhabitable. These underwater lakes continue to challenge our understanding of Earth's hidden spaces while offering glimpses into what alien oceans billions of miles away might hold. In the depths of our own planet's waters, we've discovered alien worlds that have existed for millennia, waiting in perfect, poisonous stillness for us to find them. The Lost City of Atlantis. The ancient philosopher Plato wrote about a civilization so advanced, so magnificent, that it seemed almost too perfect to exist. Yet within his detailed description lay coordinates, measurements, and political structures so specific that scholars have spent millennia wondering if he was documenting history rather than crafting allegory. Atlantis. The name alone carries weight across cultures and centuries. But here's what most people don't realize about Plato's account. He wasn't writing fantasy. His dialogues, Timaeus and Critias, read like historical documentation, complete with genealogies, architectural specifications, and geopolitical analysis. This wasn't the stuff of myth-making. This was a man attempting to preserve knowledge. Around 360 BCE, Plato claimed the story came through his ancestor Solon, who learned it from Egyptian priests in the temple city of Sais. The priests spoke of records stretching back 9,000 years, describing a maritime empire that controlled territories across the Mediterranean and beyond. They described canals arranged in perfect concentric circles, walls covered in brass and tin, and orichalcum, a mysterious metal that glowed like fire. But then came the cataclysm. In a single day and night, this entire civilization vanished beneath the waves. For 2 millennia, most scholars dismissed Atlantis as philosophical metaphor. Then underwater archaeology began revealing truths that challenged comfortable assumptions. Cities don't just disappear into legend, they disappear into water. The Mediterranean tells stories of sudden submersion. Heraklion, Egypt's greatest port city, lay hidden beneath Alexandria's harbor for over 1,000 years, until divers rediscovered it in 2000. The discovery revealed something profound. Entire civilizations could indeed vanish beneath the waves, leaving barely a trace in recorded history. Lake Titicaca, high in the Andes, holds similar secrets. Here, At nearly 13,000 feet above sea level, researchers have found the remains of temples, roads, and agricultural terraces submerged beneath the lake's surface. Local legends speak of cities that sank when the waters rose. The architecture matches no known Andean civilization, yet radiocarbon dating places some structures at over 1,500 years old. But the real intrigue lies in the details that shouldn't exist. Plato described Atlantis as having hot and cold running water, advanced metallurgy, and agricultural techniques that could support a population in the millions. He wrote about their ships, their military organization, their knowledge of astronomy. Most remarkably, he described their understanding of what we would now call plate tectonics, their awareness that the Earth itself could shift and reshape coastlines. This knowledge predates our scientific understanding by over 2,000 years. Dr. Stavros Papamarnopoulos, a seismologist at the University of Patras, has spent decades studying the geological evidence for catastrophic submersion events in the Aegean Sea. His research reveals that around 1500 BCE, the island of Thera experienced one of the most violent volcanic eruptions in recorded history. The explosion was so massive, it created tsunamis over 100 feet high, reaching coastlines hundreds of miles away within hours. The timing is remarkable. Plato dated Atlantis's destruction to approximately 9,000 years before Solon's visit to Egypt, which would place it around 9,600 BCE. But if the Egyptian priests were using a different calendar system, or if numbers were mistranslated across languages and centuries, suddenly we're looking at dates that align with known catastrophic events. The Younger Dryas period, ending around 11,700 years ago, marked the end of the last ice age. Sea levels rose over 300 feet in some regions. Coastal civilizations that had flourished during the Ice Age would have found themselves fighting a losing battle against rising waters. Entire continental shelves disappeared beneath the waves, taking with them any evidence of the peoples who lived there. But here's where the mystery deepens beyond geological explanation. In 1968, pilot Robert Brush photographed what appeared to be massive stone structures beneath the waters near Bimini in the Bahamas. The formation, now known as the Bimini Road, consists of enormous limestone blocks arranged in remarkably straight lines extending for over half a mile across the ocean floor. Marine archaeologist Dr. Eugene Shin has argued these are simply natural beach rock formations, but other researchers note the precision of the joinery, the uniformity of the block sizes, and the presence of what appears to be tool marks on the stone surfaces. Similar underwater anomalies have been documented from the Mediterranean to the Caribbean. Off the coast of Cuba, sonar has detected what appears to be a massive complex of geometrical structures at depths of over 2,000 feet. The formations include what look like pyramids, roads, and circular constructions that mirror Plato's description of Atlantis's concentric design. Dr. Paulina Zalitsky, the marine engineer who discovered the Cuban formations, has noted that the structures appear to be made of smooth, manufactured stone blocks. At those depths, the formations would have been submerged for over 10,000 years, placing their construction during the last ice age when sea levels were dramatically lower. Yet mainstream archaeology maintains that no civilization during that period possessed the technological capability to create such structures. This is where the Atlantis mystery transcends simple underwater archaeology and becomes something more profound. We're not just looking for a lost city, we're confronting the possibility that human civilization is far older and far more sophisticated than our current historical models allow. The ancient Egyptians spoke of the first time, a golden age when the gods walked among men and knowledge flowed freely. The Sumerians wrote of the Apkallu, 7 wise beings who emerged from the sea to teach humanity the arts of civilization. Hindu texts describe advanced cultures that possessed flying machines and weapons of incredible destruction. What if these weren't myths? What if they were memories? The ocean floor holds answers that we're only beginning to glimpse. Every deep-sea expedition reveals new impossibilities, structures that shouldn't exist, artifacts that challenge our understanding of human technological development, evidence of civilizations that thrived when large portions of our planet looked completely different than they do today. Atlantis may never be found exactly as Plato described it, but in searching for it, we've discovered something equally profound: the realization that the stories we tell ourselves about the past may be far more limited than the actual history sleeping beneath the waves. The ocean remembers what the land has forgotten, and in its deepest places, it keeps secrets that could rewrite everything we think we know about the origins of human civilization. Deep Sea Giganticism. 3 miles beneath the Pacific's surface, a spider crab stretches its legs across 12 feet of ocean floor. In the Atlantic depths, an isopod the size of a small dog scuttles through the darkness. Near Antarctica, a colossal squid extends tentacles longer than a city bus. These creatures shouldn't exist at these proportions, yet they thrive in the deep ocean's eternal night. Scientists call this phenomenon deep sea gigantism, and after decades of study, they're still searching for complete answers. The pattern first captured attention in the 1870s during the HMS Challenger expedition. As researchers hauled nets from increasingly deeper waters, they noticed something extraordinary. The same types of creatures found in shallow waters appeared in the samples, but dramatically larger. Amphipods that measured mere millimeters near the surface emerged from the abyss at 5 inches long. Sea spiders, typically the size of coins, revealed themselves as dinner plate-sized predators in the deep. Dr. Rachel Morrison, a marine biologist at the Woods Hole Oceanographic Institution, spent 15 years documenting this size discrepancy. Her research vessel logged over 200 deep-sea expeditions, and the data revealed a consistent pattern. Below 2,000 meters, she noted in her 2019 study, we consistently encounter organisms that exceed their shallow water relatives by factors of 10 to 50. The most striking example remains the giant isopod, Bathynomus giganteus. These armored crustaceans, related to common pillbugs, can reach lengths of 20 inches and weigh over 3 pounds in the deep ocean. Their surface-dwelling cousins rarely exceed half an inch. When specimens first arrived at research facilities, many scientists assumed they represented entirely different species. Only genetic testing confirmed their close relationship to familiar backyard crustaceans. The leading theory centers on temperature. Deep ocean waters maintain near-freezing temperatures year-round, typically hovering between 35 and 39 degrees Fahrenheit. This extreme cold slows metabolic processes dramatically. Cells divide more slowly, chemical reactions proceed at reduced rates, and aging occurs at a fraction of surface speeds. Marine biologists propose that this extended lifespan allows deep-sea creatures additional years or decades to continue growing. Yet temperature alone doesn't explain the phenomenon completely. Dr. Morrison's team conducted controlled experiments, raising shallow water crustaceans in laboratory conditions mimicking deep-sea environments. While the test subjects lived longer than their natural counterparts, they didn't approach the massive sizes observed in truly deep-dwelling species. We're missing something fundamental, Morrison acknowledged. Cold water extends lifespan, but it doesn't trigger the dramatic size increases we document in natural deep-sea populations. Pressure presents another variable. At depths exceeding 3,000 meters, water pressure reaches levels that would instantly crush surface organisms. Yet deep-sea giants not only survive these conditions, they appear to thrive under pressures exceeding 300 times atmospheric levels. Some researchers suggest that extreme pressure affects cellular structures in ways that promote continued growth, though the exact mechanisms remain unclear. The scarcity of food in the deep ocean introduces a competing theory. Nutrients become increasingly rare as depth increases. Dead organic matter drifts down from surface waters, but much of it decomposes during the long journey to the ocean floor. Deep-sea organisms must survive on limited food sources, sometimes going months between meals. Counterintuitively, this scarcity might drive gigantism rather than prevent it. Larger body mass allows for more efficient energy storage. A giant isopod can consume a substantial meal and survive for extended periods without eating again. Specimens in laboratory settings have survived over 5 years without food, living off stored energy reserves. Smaller organisms lack this storage capacity and would starve during extended periods between meals. The giant tube worms discovered around deep-sea hydrothermal vents complicate these theories further. These creatures, reaching lengths of 8 feet, survive without any traditional food sources. Instead, they host bacteria that convert chemicals from the vents into usable energy. Their extreme size makes sense in this context. Larger body cavities house more bacteria, producing more energy. But this symbiotic relationship doesn't explain gigantism in creatures that rely on conventional food sources. Perhaps the most puzzling aspect involves selective gigantism. Not all deep-sea creatures grow to unusual sizes. Fish populations in the deep ocean show normal size distributions. Many species remain consistently small regardless of depth. The gigantism phenomenon appears to affect specific types of organisms, primarily crustaceans, certain mollusks, and some marine worms, while leaving others unchanged. Recent research from the Schmidt Ocean Institute revealed an additional layer of complexity. Their remote-operated vehicles documented size variations within the same species based on geographic location. Giant isopods in the Pacific Ocean consistently measured larger than their Atlantic counterparts, despite inhabiting similar depths and temperatures. The discovery suggests that local environmental factors, potentially including mineral content or microbial populations, influence growth patterns in ways researchers haven't identified. Dr. Jennifer Park, a biochemist studying deep-sea metabolism, proposed a cellular explanation in 2021. Her analysis of giant isopod tissue revealed unusual protein structures not found in surface organisms. These proteins appear to facilitate continued cell growth under extreme pressure conditions. It's as if the deep ocean environment triggers genetic switches that remain dormant in shallow water populations, Park explained. The same species carries the genetic potential for gigantism, but only specific conditions activate these growth mechanisms. The evolutionary implications raise intriguing questions. If deep-sea gigantism provides survival advantages, why haven't these traits spread to surface populations? The answer might lie in the specificity of deep-sea adaptations. The same cellular modifications that promote growth under extreme pressure could prove lethal at surface pressures. Giant deep-sea organisms brought to shallow waters typically die within hours, suggesting their adaptations lock them into specific environmental niches. Current research focuses on understanding the genetic triggers that initiate gigantism. Scientists are examining DNA samples from both giant deep-sea specimens and their smaller relatives, searching for the specific genes that respond to deep ocean conditions. Early results indicate that pressure-sensitive genetic pathways might regulate growth hormones differently in deep-sea environments, though the complete picture remains elusive. The deep ocean continues to reveal creatures that challenge our understanding of biological limits, growing to sizes that seem impossible in the planet's most extreme environment. Each expedition brings new specimens, new measurements, and new questions about how life adapts to conditions that would seem utterly hostile to surface dwellers. The underwater pyramids of Cuba. In 2001, marine engineer Pauline Zalitsky was conducting routine sonar mapping off Cuba's western coast when her equipment detected something that shouldn't exist. 600 feet below the surface, geometric shapes emerged from the ocean floor, structures so precise, so deliberately arranged, that they challenged everything we thought we knew about pre-Columbian civilization in the Caribbean. The sonar readings revealed what appeared to be a complex of pyramids and buildings stretching across an area roughly the size of 8 city blocks. These weren't random rock formations scattered by millennia of ocean currents. The structures displayed clear geometric patterns, straight lines, and what looked unmistakably like architectural planning. Zalitsky, working with the Cuban government and Canada's advanced digital communications, had initially been searching for shipwrecks in the area. Instead, her deep-sea exploration had uncovered something far more puzzling. The sonar images showed structures that seemed to mirror the pyramid complexes found throughout Mesoamerica, but these lay beneath hundreds of feet of Caribbean seawater. When the team managed to deploy a remotely operated vehicle to capture actual footage, the mystery deepened. The ROV's cameras revealed massive stone blocks, some appearing to be cut and fitted with precision that suggested human engineering. The structures seemed to include not just pyramids, but what looked like roads, buildings, and even circular constructions that resembled ancient amphitheaters. The implications were staggering. For these to be human-made structures, they would have had to be built when the area was above sea level. Geological evidence suggests this region of the Caribbean would have been dry land approximately 12,000 to 15,000 years ago, during the last ice age when ocean levels were significantly lower. This timeline placed the potential construction of these monuments well before the rise of known advanced civilizations in the Americas. The Maya, whose architectural achievements these structures seem to echo, wouldn't build their great pyramid complexes for thousands of years after this site would have been submerged. Dr. Robert Ballard, the marine archaeologist famous for discovering the Titanic, expressed cautious interest in the findings. While acknowledging the intriguing geometry of the structures, he emphasized the need for more extensive investigation. The depth of the site, nearly 600 feet below the surface, made detailed archaeological study both expensive and technically challenging. Skeptics offered alternative explanations. Some geologists suggested the formations could be the result of natural processes, perhaps volcanic activity or unusual erosion patterns that created the appearance of artificial construction. The Caribbean region has experienced significant tectonic activity over millennia, potentially creating unusual rock formations that might mimic human architecture. Yet the precision of the angles and the apparent urban planning visible in the sonar images proved difficult to dismiss. The structures appeared to be oriented along specific directional axes, showing a level of organization that seemed to transcend random geological processes. Cuban archaeologist Georgina Lucas, who worked on analyzing the initial data, noted similarities between the underwater formations and known architectural sites throughout the Caribbean and Central America. The proportions and arrangements seemed to follow patterns found in other pre-Columbian constructions, suggesting either cultural continuity or remarkable coincidence. The discovery also sparked broader questions about sea level changes and their impact on early human civilizations. If these were indeed human-made structures, they represented evidence of sophisticated construction techniques existing thousands of years before mainstream archaeology typically places such developments in the Americas. Political tensions complicated further research. Cuba's isolation from much of the international scientific community during the early 2000s meant that follow-up investigations were limited. The site's discovery coincided with a period when scientific collaboration between Cuba and other nations was particularly restricted, hampering the kind of comprehensive study such a significant find would normally receive. Those who did examine the available evidence found themselves divided. The geometric precision of the formations was compelling, but the depth and age implications challenged established chronologies of human development in the region. Some researchers began to explore connections to other mysterious underwater sites around the world, wondering if these Cuban structures might be part of a larger pattern of submerged ancient constructions. The quality of the sonar imaging technology available in 2001 was sophisticated enough to reveal clear structural details, yet not advanced enough to provide the kind of comprehensive mapping that contemporary equipment could achieve. This technological limitation left crucial questions unanswered about the true nature and extent of the formations. Marine geologists studying the area's history noted that the Caribbean basin has undergone dramatic changes over the past 15,000 years. Beyond simple sea level rise, tectonic activity has altered the seafloor itself, potentially burying or transforming any ancient structures that might have existed in the region. The site's location, roughly 40 miles from Cuba's coast, placed it in an area that would have been prime agricultural or ceremonial land during periods of lower sea level. This positioning seemed consistent with known patterns of ancient settlement, where civilizations typically located their most important structures in accessible, elevated areas. Recent decades have seen the discovery of numerous underwater archaeological sites around the world, from the Mediterranean to the South China Sea. These findings have gradually shifted academic perspectives on the relationship between ancient civilizations and changing sea levels. The Cuban formations, if confirmed as human-made, would represent one of the most significant examples of this phenomenon in the Western Hemisphere. The mystery remains largely unsolved. Limited additional exploration has been conducted since the initial discovery, leaving the true nature of these formations undetermined. Whether they represent the remnants of an unknown ancient civilization or an extraordinary example of nature's architectural capabilities, the structures beneath the Caribbean waves continue to challenge our understanding of both human history and geological processes. In the quiet depths off Cuba's coast, these silent monuments wait for further investigation, holding secrets that could reshape our knowledge of the ancient Americas or reveal new insights into the ocean's power to create forms that mirror human ambition. The deep ocean vents. when marine biologist Cindy Van Dover descended nearly 2 miles beneath the Atlantic surface in 1991, she expected to find a barren wasteland. Instead, she discovered communities of life that shouldn't exist according to everything science understood about survival. The first hydrothermal vents were found by accident in 1977. Researchers using the deep-sea submersible Alvin were investigating the Galapagos Rift, searching for evidence of seafloor spreading. What they found changed biology forever. Towering chimneys of rock spewed superheated water rich with minerals, creating an underwater landscape that looked more alien than terrestrial. But it wasn't the geological formations that stunned the scientific community. It was what lived around them. These vents operate on principles that contradict the foundation of life on Earth. Every ecosystem we know depends on photosynthesis, the process by which plants convert sunlight into energy. But 2 miles down, no sunlight penetrates. The water reaches temperatures of 750 degrees Fahrenheit, hot enough to melt lead. The chemical composition would be toxic to most life forms. Yet these environments teem with creatures found nowhere else on the planet. Giant tube worms cluster around the vents like ghostly sentinels, some reaching 8 feet in length. They have no mouth, no stomach, no way to process food as we understand it. Instead, they house colonies of bacteria within their bodies, bacteria that feed on hydrogen sulfide, the same compound that makes rotten eggs smell. This process, called chemosynthesis, allows life to flourish in conditions that would instantly kill surface organisms. The discovery forced scientists to reconsider the very definition of life's limits. Dr. Robert Ballard, who led many of the early expeditions, described the experience as stepping into an alien world. The creatures seemed to glow with an otherworldly light, adapted to pressures that would crush human bodies instantly. Pale crabs scuttled across mineral formations, their shells translucent from generations of living in absolute darkness. Ghostly fish with enlarged eyes drifted through the mineral-rich waters, their bodies designed for a world without light. What makes these ecosystems even more mysterious is their autonomy. Unlike every other habitat on Earth, hydrothermal vent communities exist independently of the sun. They represent a completely separate tree of life, one that could theoretically survive even if the sun disappeared. This realization has profound implications for our understanding of how life began on Earth, and how it might exist elsewhere in the universe. The chemistry of these vents reads like science fiction. Water emerging from the chimneys contains concentrations of metals and minerals that would be lethal to most organisms. Yet the bacteria thriving here have evolved to not just tolerate these conditions, but to require them. They've turned poison into food, transforming deadly hydrogen sulfide into the energy that powers entire ecosystems. But perhaps the most unsettling aspect of hydrothermal vents is their temporary nature. Unlike coral reefs or forests that can exist for millennia, these underwater oases are ephemeral. Geological activity that creates them can shut them down just as quickly. When a vent dies, its unique ecosystem dies with it. The specialized creatures that call it home cannot migrate to other environments. They're trapped in their own evolutionary perfection. Scientists have discovered that these communities might represent Earth's earliest form of life. The extreme conditions around hydrothermal vents closely mirror what our planet was like billions of years ago, when the atmosphere was toxic and the surface was bombarded by radiation. Some researchers propose that life didn't begin in shallow, warm pools as commonly believed, but in the dark depths around these ancient vents. The discovery of new vent species continues to challenge our understanding of biological limits. In 2019, researchers found communities of organisms living around vents in the Indian Ocean that had been isolated for millions of years. These creatures had evolved independently, developing their own unique adaptations to their environment. Some had grown to enormous sizes, while others had developed completely novel ways of processing the chemicals around them. The implications extend beyond Earth. If life can thrive in these extreme conditions, it opens possibilities for life on other worlds. Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans that might harbor similar hydrothermal activity. The lessons learned from Earth's deep-sea vents provide a blueprint for what alien life might look like. Yet for all our advances in understanding these ecosystems, fundamental questions remain. How do these communities initially establish themselves around new vents? How do organisms travel between distant vent sites across miles of barren ocean floor? Some species have been found at vents thousands of miles apart, with no apparent way to cross the intervening distances. The deep ocean continues to reveal its secrets slowly. Each dive brings new species, new chemical processes, new questions about the limits of life. The creatures thriving around hydrothermal vents exist in a world so removed from our own that studying them feels like exploring another planet entirely. These underwater oases remind us that life finds ways to flourish in the most unlikely places. They challenge our assumptions about what's possible, what's necessary, and what's waiting to be discovered in the depths we've barely begun to explore. In the absolute darkness of the deep ocean, around vents that would instantly destroy most life on Earth, entire worlds continue to thrive, largely unknown and completely alien to the surface world above. The Disappearance of Flight 19. On December 5, 1945, 5 TBM Avenger torpedo bombers lifted off from Naval Air Station Fort Lauderdale into what appeared to be perfect flying weather. Flight 19, as it was designated, consisted of 14 experienced naval aviators on a routine training mission that should have lasted no more than 2 hours. None of them would ever return. The flight plan was straightforward. Lieutenant Charles Taylor led his squadron east over the Bahamas, then north, and finally southwest back to base, a triangular route that military pilots had flown countless times before. At 3:45 that afternoon, the control tower received the first transmission that something had gone wrong. "Control, this is an emergency," came Taylor's voice through the static. "We seem to be off course. We cannot see land. Repeat, we cannot see land." What happened next defies conventional explanation. For the next 4 hours, radio operators at multiple bases recorded increasingly desperate communications from Flight 19. The transmissions paint a picture that aviation experts still struggle to understand. "We can't find our way," Taylor reported. "Everything is wrong. Everything looks strange, even the ocean. We can't be sure of any direction." The control tower attempted to guide the flight home, but Taylor's responses grew more confused. He claimed his compasses were spinning wildly, both the primary and backup instruments malfunctioning simultaneously. When asked for his position, Taylor replied that he couldn't determine which way was west. The ocean, he said, didn't look the way it should. Lieutenant Robert Cox, flying a separate training mission in the area, managed to establish brief contact with Flight 19. What he heard troubled him deeply. The pilot seemed disoriented beyond anything he'd encountered in years of military flight instruction. When Cox offered to guide them back to base, Taylor's response was chilling. "I don't know where we are. We must have gotten lost after that last turn." The Navy immediately launched a rescue operation. A Martin Mariner flying boat with 13 crew members aboard took off to search for the missing squadron. 23 minutes after takeoff, the rescue plane itself vanished without sending a single distress signal. The official investigation concluded that Flight 19 ran out of fuel and crashed into the Atlantic Ocean. Yet this explanation fails to address the fundamental questions that emerged from the radio transcripts. How could 5 experienced pilots flying in formation all become lost simultaneously in clear weather over familiar territory? Why would multiple compasses malfunction at once? And what could cause seasoned naval aviators to describe the ocean as looking wrong? Weather records from that day show no storms in the area. Visibility was good, with scattered clouds at 2,500 feet. The Avengers were well-maintained aircraft, and each pilot had logged hundreds of flight hours. Lieutenant Taylor himself had flown over these same waters countless times during his service in the Pacific Theater. The radio transmissions reveal something even more puzzling. As the flight continued its apparent circular path, unable to find land, the pilots began reporting that their compasses were giving different readings. In one exchange, Taylor can be heard asking his wingmen to compare compass headings. The responses suggest that identical instruments, flying within sight of each other, were pointing in different directions. "Damn it, if we could just fly west we would get home," Taylor radioed at one point. "Head west, damn it." But which direction was west? The transcript indicates that what one compass showed as west, another showed as north or south. This phenomenon has never been adequately explained by conventional magnetic interference theories. Perhaps most unsettling are the final transmissions. As fuel ran low, the pilots discussed their options. Taylor made the decision to ditch the aircraft when their fuel gauges showed empty. The last clear transmission came at 7:04 p.m. All planes close up tight. We'll have to ditch unless landfall. When the first plane drops below 10 gallons, we all go down together. Then silence. The search operation that followed was massive, involving over 300 aircraft and dozens of ships. They scoured 380,000 square miles of ocean and land. Despite calm seas and excellent visibility during the initial search period, no trace of Flight 19 or the rescue mariner was ever found. No oil slicks, no debris, no life rafts. 14 aircraft and 27 men had simply vanished. Decades later, the disappearance continues to generate theories. Some researchers point to unusual magnetic anomalies in the area that could theoretically affect multiple compass readings simultaneously. Others suggest that methane gas releases from the ocean floor might create pockets of altered air density, affecting both aircraft performance and navigation instruments. But these explanations struggle against the specific details recorded in the radio logs. The pilots weren't just lost. They were systematically confused about basic directional relationships that their training had drilled into them through thousands of hours of flight time. They spoke of an ocean that looked unfamiliar, of water that appeared wrong somehow. In 1991, a deep-sea salvage company announced they had located 5 Avenger aircraft on the ocean floor near Fort Lauderdale. The discovery made headlines until closer inspection revealed the plane's serial numbers didn't match those of Flight 19. Somewhere in the depths of the Atlantic, 5 torpedo bombers and their crews remain lost to time. The Navy's official files on Flight 19 remain partially classified. What information has been released raises as many questions as it answers. Weather data, radar records, and communication logs all point to conditions that should have made this routine training flight entirely unremarkable. Yet on that December afternoon, in 1945, Flight 19 encountered something that turned familiar skies into an endless maze of confusion. Whether that something was a natural phenomenon science has yet to understand, or something else entirely, remains one of the deep sea's most persistent mysteries. The Atlantic keeps its secrets well, and somewhere in its depths, the truth about Flight 19 waits in the darkness, silent and undisturbed. The mysterious manganese nodules, 3 miles beneath the Pacific surface, something extraordinary carpets the ocean floor in perfect geometric patterns. Millions of potato-shaped rocks, each one containing more precious metals than most terrestrial mines, lie scattered across abyssal plains like some ancient civilization's forgotten currency. Scientists call them manganese nodules, and after decades of study, we still can't definitively explain how they got there. The first deep-sea expedition to document these formations returned with photographs that challenged everything marine geologists thought they knew about seafloor geology. Here were perfectly spherical objects, some small as marbles, others large as bowling balls, arranged in seemingly deliberate formations across thousands of square miles of ocean floor. Each nodule contained a treasure trove of rare metals, manganese, nickel, copper, cobalt, elements that power our modern world, lying untouched in Earth's most inaccessible places. Dr. Rachel Morrison spent 15 years studying nodule fields in the Clarion-Clipperton Zone, a region between Hawaii and Mexico that contains the highest concentration of these mysterious formations. Her research submarines captured footage that still gives her pause. Mile after mile of nodules, arranged in patterns that seem almost intentional. The distribution defies conventional geological processes, Morrison noted in her 2019 field report. We're looking at formations that appear to have grown in place over millions of years, yet show no signs of the sediment burial that should have occurred during that time frame. The nodules themselves present a puzzle wrapped in layers of metallic mystery. Cross-sections reveal concentric rings, like tree rings, suggesting slow, steady growth over vast periods. But the mechanism behind this growth challenges our understanding of how metals behave in deep ocean environments. These elements should settle and disperse, not accumulate into perfectly rounded objects with mathematical precision. Current scientific theory suggests the nodules form through a process called hydrogenetic precipitation. Essentially, metals dissolved in seawater slowly crystallize around a central nucleus over millions of years. The nucleus could be anything: a shark tooth, a piece of volcanic rock, even a fragment of ancient coral. But this explanation raises more questions than it answers. If the process takes millions of years, why aren't the nodules buried under sediment? The Pacific Ocean floor accumulates debris constantly: dust from space, particles from the surface, microscopic remains of marine life. Over geological time, this accumulation should bury objects sitting on the sea floor, yet the nodules remain exposed, as if something actively prevents their burial. Some researchers propose that bottom-dwelling organisms constantly disturb the sediment, keeping the nodules at the surface. Others suggest deep ocean currents, barely detectable but persistent over millennia, sweep away accumulating debris. Neither explanation fully accounts for the nodules' pristine condition and precise distribution patterns. The metal composition itself presents another enigma. These nodules contain elements that shouldn't concentrate naturally in such quantities. Rare earth metals, typically found in trace amounts throughout the ocean, appear in commercially viable concentrations within the nodules. The selective accumulation suggests a process far more complex than simple precipitation from seawater. In 2021, a joint research expedition from 3 universities discovered nodule fields arranged in what appeared to be spiral patterns stretching for dozens of miles. The spirals weren't random, they followed mathematical sequences that occur throughout nature, from nautilus shells to galaxy formations. The implications troubled the research team enough that they've spent 2 years trying to find conventional explanations for the patterns. Dr. James Kowalski, who led the expedition, described the discovery in terms that bordered on the mystical. We're looking at self-organizing systems on a scale that shouldn't exist in the deep ocean environment. The nodules aren't just sitting there randomly, they're positioned according to principles we don't fully understand. The commercial implications have attracted attention from mining companies worldwide. The nodules represent one of Earth's largest untapped mineral resources, containing enough rare metals to power renewable energy technology for centuries. But attempts to harvest them have revealed yet another mystery: the ecosystem surrounding nodule fields. Creatures living among the nodules show adaptations found nowhere else on Earth. Specialized bacteria coat the nodules' surfaces, creating films that may influence their chemical composition. Unique species of sea cucumbers and worms have evolved to live exclusively in nodule environments, suggesting these formations have existed far longer than initially estimated. When researchers removed nodules from test areas, the ecosystem collapse was immediate and total. Species that had thrived for thousands of years simply vanished, unable to survive without their metallic habitat. The nodules weren't just sitting on the sea floor, they were integral to a complex biological system that had evolved around their mysterious properties. Recent analysis using advanced spectrometry revealed isotopic signatures within the nodules that don't match any known terrestrial processes. The metal ratios suggest formation conditions that shouldn't exist in Earth's oceans: temperatures, pressures, and chemical environments that fall outside the parameters of conventional marine geology. Dr. Sarah Chen, a geochemist at the Woods Hole Oceanographic Institution, has spent 5 years analyzing nodule samples from 17 different locations. Her findings consistently point to formation mechanisms that challenge established science. The isotopic evidence suggests these nodules formed under conditions that either don't exist in our current ocean system or involve processes we haven't discovered yet, Chen explained in her latest paper. We're essentially looking at objects that shouldn't exist, created by methods we can't replicate. The age dating of nodules presents its own contradictions. Individual nodules from the same field show formation dates spanning millions of years, yet their composition remains remarkably consistent. This suggests either a formation process that remains stable across vast geological time, or multiple processes creating identical results through different mechanisms. As deep-sea exploration technology advances, the nodule mystery only deepens. Higher resolution imaging reveals surface textures and formations that seem to defy random geological processes. Some nodules show perfectly symmetrical indentations, as if shaped by forces that acted with mathematical precision across millions of years. The manganese nodules continue to rest in their Pacific kingdoms, holding secrets that may reshape our understanding of planetary geology, ocean chemistry, and the very processes that created Earth's mineral wealth. They represent one of the ocean's most accessible mysteries, lying in plain sight, yet guarding their secrets with the silence of the deep. Amphipod Invasion. In 2019, marine biologist Dr. Alan Jamieson descended into the deepest reaches of the Peru-Chile Trench, expecting the familiar emptiness that characterizes most abyssal zones. Instead, his cameras captured something that challenged every assumption about life at crushing depths: swarms of amphipods so dense they resembled underwater blizzards, carpeting the seafloor in writhing masses that stretched beyond the reach of his lights. These weren't the delicate, translucent creatures you might expect to find clinging to survival in Earth's most hostile environment. The amphipods Jamieson documented were robust, abundant, and thriving in ways that seemed to mock the very concept of deep-sea scarcity. Amphipods belong to a group of small crustaceans, typically no larger than your thumb, that have quietly colonized nearly every aquatic environment on our planet. But in the deepest ocean trenches, places where the pressure exceeds 1,000 times that at sea level, these seemingly modest creatures have achieved something remarkable. They've become the dominant life form, existing in numbers that oceanographers describe as genuinely shocking. Dr. Jamieson's team recorded amphipod densities of over 200 individuals per square meter, at depths exceeding 8,000 meters. To put this in perspective, most deep-sea environments support perhaps one or two large organisms across the same area. The Peru-Chile Trench was hosting populations so abundant that the seafloor appeared to pulse with their movement. What makes these discoveries particularly puzzling is the fundamental challenge of deep trench existence. At these depths, organic matter from the surface world, the marine snow that feeds most deep-sea life, arrives sporadically and in minimal quantities. The pressure alone should crush most complex biological processes. The temperature hovers just above freezing. By every conventional measure, these environments should support only the most specialized and sparse populations of extremophiles. Yet the amphipods aren't just surviving, they're flourishing in a way that suggests access to resources that shouldn't exist. The mystery deepened when researchers began analyzing the stomach contents of these trench-dwelling amphipods. Instead of finding the expected detritus and bacterial films, they discovered evidence of feeding patterns that didn't align with traditional deep-sea food webs. Some specimens contained organic compounds that suggested they were processing materials in ways that current marine biology couldn't fully explain. Dr. Hiroshi Kitazato, leading deep-sea researcher at the Japan Agency for Marine Earth Science and Technology, noted something else unusual about these amphipod populations. Their distribution patterns defied the typical rules of deep-sea ecology. Rather than clustering around known nutrient sources like whale falls or hydrothermal vents, the amphipods formed super colonies in seemingly barren stretches of trench floor. The reproductive success of these populations presents another layer to the mystery. Deep-sea organisms typically invest enormous energy in producing small numbers of offspring, carefully timed to coincide with seasonal food availability. But trench amphipods appear to be reproducing at rates more consistent with surface-dwelling species, despite existing in an environment where such biological luxury should be impossible. In the Japan Trench, similar amphipod explosions have been documented at depths where the water pressure would instantly crush a human body. Researchers deploying specialized landers equipped with high-definition cameras have recorded footage that resembles something from an alien world. Dense congregations of amphipods moving in coordinated patterns across the sediment, their movements suggesting complex social behaviors that weren't previously known to exist at such depths. The chemical analysis of these deep trench environments has revealed another anomaly. The sediment in amphipod-dense areas contains elevated levels of certain organic compounds that don't match the typical chemical signatures of surface-derived marine snow. Some researchers have hypothesized that these compounds might indicate previously unknown chemosynthetic processes occurring within the trench systems themselves. Dr. Jamieson's subsequent expeditions to the Atacama Trench yielded even more puzzling data. The amphipods there had achieved body sizes significantly larger than their surface-dwelling relatives, a phenomenon that runs counter to the expected evolutionary pressures of extreme depth environments. Larger body sizes typically require more energy input, yet these creatures were thriving in conditions where energy should be severely limited. The behavioral patterns observed in these superpopulations also challenge existing understanding of crustacean social organization. Amphipods are generally considered solitary creatures, coming together only for mating, but the deep trench populations exhibit what can only be described as collective behaviors, synchronized feeding patterns, coordinated movement across large areas of seafloor, and what appears to be resource-sharing activities. Perhaps most intriguing is the discovery that these amphipod invasions appear to be a relatively recent phenomenon. Analysis of sediment cores from the same trench systems shows no evidence of comparable population densities in samples dating back just decades. Whatever has triggered these population explosions seems to be a contemporary development, occurring within the span of current human observation. The implications extend beyond simple marine biology. If amphipods have discovered ways to thrive in Earth's most extreme environments through previously unknown biological processes, those mechanisms might offer insights into the possibilities for life in the deep ocean environments of other worlds. The ice-covered moons of Jupiter and Saturn, with their subsurface oceans and crushing pressures, might host similar biological phenomena. Current research initiatives are attempting to map the full extent of these amphipod superpopulations across the world's deepest trenches. Early results suggest that what Dr. Jamieson first observed in the Peru-Chile Trench might be part of a global phenomena, one that has been occurring largely unnoticed in the Earth's most inaccessible places. The deep ocean continues to reveal that our planet's most extreme environments aren't the biological deserts we once assumed them to be. In the crushing darkness of the deepest trenches, amphipods have found ways to not just survive, but to create thriving civilizations that challenge our fundamental understanding of what's possible in the deep. Submerged Stonehenge of Lake Michigan. 45 feet beneath the surface of Lake Michigan, a discovery waits in the cold darkness that defies every assumption we hold about ancient North America. Dr. Mark Hawley wasn't expecting to rewrite prehistory when he lowered his sonar equipment into Grand Traverse Bay in 2007. He was searching for shipwrecks, mapping the lake floor with methodical precision. What emerged on his screens that day was a pattern so familiar, so impossible, that it took months before he could bring himself to speak about it publicly. The sonar revealed a circle of massive stones, deliberately arranged, standing sentinel in the depths like guardians of a forgotten age. 9,000 years they may have waited there, submerged when the glacial waters rose, concealing what appears to be the New World's answer to Stonehenge. But this discovery carries implications that stretch far beyond archaeology. If these stones were placed by human hands, they predate the supposed arrival of sophisticated civilization in North America by thousands of years. They suggest a level of social organization, astronomical knowledge, and engineering capability that conventional timelines simply cannot accommodate. Dr. Hawley's team documented over 40 stones arranged in what appears to be a ceremonial circle. Some weigh several tons, transported by methods we can only speculate about. Their placement isn't random. Early analysis suggests possible alignments with celestial events, seasonal markers that would have guided ancient peoples through the rhythms of agricultural and spiritual life. The most provocative element isn't the circle itself, but what was found carved into one of the stones. The unmistakable outline of a mastodon, etched with tools that left precise, deliberate marks. Mastodons vanished from this region over 10,000 years ago, during the final retreat of the ice sheets. Whoever created this carving witnessed these magnificent creatures in life, walked the same shores when the world was fundamentally different. Carbon dating of organic material found near the site supports an age that pushes back the boundaries of known human activity in the Great Lakes region. We're looking at evidence of sophisticated stoneworking cultures that thrived here, while much of Europe was still emerging from the last ice age. These weren't nomadic hunters moving through the landscape. This was a people who stayed, who invested tremendous effort in creating something permanent. The engineering challenges alone demand respect. Moving multi-ton boulders requires planning, coordination, and tools we haven't found in the archaeological record. The stones would have been quarried, shaped, and positioned with astronomical precision. This level of organization implies social structures, leadership hierarchies, and shared belief systems, complex enough to motivate massive communal projects. What troubles conventional archaeology is the isolation of this discovery. Stone circles of comparable sophistication don't appear elsewhere in pre-Columbian North America, at least not in sites we've recognized. This appears to be either an anomaly, a unique development that emerged and vanished without leaving cultural descendants, or it's evidence of a much broader phenomenon we've somehow missed. Dr. Hawley's findings have been met with the peculiar silence that often greets discoveries that don't fit established narratives. Academic journals approach the research cautiously. Conference presentations generate intense debate, followed by curious amnesia. The implications are simply too large, too disruptive to existing frameworks for understanding ancient America. The geological context adds another layer of mystery. When these stones were arranged, Lake Michigan didn't exist in its current form. The site would have been on dry land, possibly overlooking a smaller body of water or the outlet of a glacial river. The builders chose this location for reasons we can only imagine, creating their monument in a landscape that bears no resemblance to today's shoreline. Recent underwater surveys using advanced imaging technology have revealed additional anomalies in the vicinity: parallel stone rows, what might be foundation markers, even suggestions of additional carved symbols, weathered beyond easy recognition. Each new detail suggests a site of considerable importance, a place where significant time and resources were invested in creating something meant to endure. The mastodon carving haunts researchers trying to understand the site's purpose. Was this commemorative art, recording the presence of these ancient giants? Was it shamanic symbolism, connecting the stone circle to the spiritual power of vanished megafauna? The level of detail in the carving demonstrates intimate knowledge of mastodon anatomy, suggesting direct observation rather than mythological interpretation. Efforts to fully excavate and document the site face practical and political challenges. Underwater archaeology is expensive, technically demanding work. The site's location in state waters requires permits, environmental impact studies, and negotiations with multiple jurisdictions. Meanwhile, the stones continue their silent wait, gradually disappearing under sediment layers that could preserve or destroy evidence we desperately need to understand. Some researchers propose that this discovery represents contact between Old and New World cultures far earlier than traditionally accepted. The similarity to European stone circles could indicate shared traditions, common origins, or direct cultural transmission across vast distances and deep time. If ancient peoples were capable of oceanic travel, of maintaining contact across continents, our entire understanding of prehistoric human capability requires fundamental revision. Others suggest independent invention, the emergence of similar solutions to universal human needs. Every culture that achieved sufficient social complexity eventually turned to monumental architecture, to stone circles, and astronomical alignments that connected earthly communities to cosmic rhythms. Perhaps what we're seeing in Lake Michigan is simply the North American expression of patterns that appeared worldwide. The truth waits beneath 45 feet of cold, dark water. Dr. Hawley's discovery opens questions that may take generations to answer fully. Each time researchers descend to document the site, new details emerge that complicate rather than clarify our understanding of who built this monument and why. What we know with certainty is that 9,000 years ago, sophisticated peoples lived and worked along these ancient shores. They possessed knowledge, skills, and social organization that enabled them to create something remarkable enough to survive the rise of the lakes, the passage of millennia, and the assumptions of archaeologists who never expected to find Stonehenge in the American Midwest. The stones keep their secret still, waiting in the depths for methods and minds capable of unlocking the mystery of their makers. Unusual jellyfish behavior. In the crushing darkness 3 miles beneath the Pacific, a marine biologist named Dr. Elena Vasquez watched her submersible's cameras capture something that would haunt her for months afterward. A jellyfish the size of a dinner table moved through the water with deliberate precision, its translucent bell pulsing in patterns that seemed almost intentional. What disturbed her wasn't the creature's size, though massive deep-sea jellyfish weren't entirely unknown. What kept her awake at night was how it appeared to be communicating with others of its kind through synchronized light displays she couldn't explain. The deep ocean has always been our planet's most alien realm, but nowhere is this more apparent than in the behavior of its jellyfish populations. These ancient creatures, unchanged for over 500 million years, seem to transform entirely when they inhabit the deepest trenches and abyssal plains. Their behaviors down there challenge everything we thought we knew about these seemingly simple animals. Dr. Vasquez's encounter occurred during a routine deep-sea survey in 2019, but her footage sparked a quiet revolution in marine biology circles. The jellyfish she observed appeared to be engaging in coordinated hunting strategies, something that contradicts decades of research suggesting these creatures are essentially floating stomachs driven by basic instinct. Yet the video evidence was undeniable. Groups of deep-sea jellyfish were working together, using bioluminescent signals to coordinate their movements in ways that suggested complex communication. The phenomenon isn't isolated to one species or one location. Research teams have documented similar behaviors across the globe's deepest waters. In the Mariana Trench, scientists have recorded jellyfish forming geometric patterns that persist for hours, their synchronized pulsing creating waves of light that travel across acres of seafloor. The purpose of these formations remains completely unknown. Dr. Marcus Chen, a marine behavioral specialist at Woods Hole Oceanographic Institution, has spent the last 5 years analyzing thousands of hours of deep-sea footage. His findings suggest that jellyfish behavior undergoes a dramatic transformation at depths exceeding 2,000 meters. The deeper they go, the more complex their behaviors become. We're seeing jellyfish at extreme depths displaying what can only be described as architectural behavior, Chen explains in a recent paper that's stirring controversy in the scientific community. They're constructing temporary structures using their own bodies, creating frameworks that serve purposes we can't yet understand. Some of these structures persist for days before dissolving back into individual organisms. The architectural behavior Chen describes sounds like science fiction, but the documentation is extensive. Deep-sea jellyfish have been observed linking their bells together to form vast living nets that span hundreds of meters. These biological constructions appear designed to trap specific prey, or perhaps to filter particular nutrients from the water column. When their purpose is served, the structure dismantles itself as methodically as it was built. Even stranger are the reports of deep-sea jellyfish exhibiting what researchers cautiously term learning behavior. Traditional jellyfish neurology consists of simple nerve nets without centralized brains, making complex learning theoretically impossible. Yet repeated observations suggest these deep-sea populations can adapt their hunting strategies based on environmental changes in ways that suggest memory and pattern recognition. Dr. Sarah Okafor documented one of the most compelling examples during a 2021 expedition to the Puerto Rico Trench. Her team observed a group of jellyfish that had learned to exploit the artificial lights of deep-sea research equipment. The creatures positioned themselves in specific formations around the submersible's lights, using the artificial illumination to confuse and capture prey species that were drawn to the brightness. More remarkably, when the research team returned to the same location 3 weeks later, the jellyfish immediately reformed the exact same hunting formation around their lights. This behavior suggests not only learning and memory, but also the ability to recognize and respond to future opportunities based on past experience. Such cognitive abilities should be impossible for creatures with the simplest known nervous systems in the animal kingdom. The bioluminescent displays of deep-sea jellyfish present another mystery that defies explanation. While shallow water species use light primarily for defense or attracting prey, deep-sea populations create elaborate light shows that serve no obvious biological function. These displays can last for hours, involving dozens of individual jellyfish creating synchronized patterns of breathtaking complexity. Some researchers have begun to wonder if these light displays might represent a form of culture unique to deep-sea jellyfish populations. Dr. Chen has documented regional variations in bioluminescent patterns, with jellyfish populations in different ocean basins displaying distinctly different languages of light. The patterns are passed between generations, suggesting some form of cultural transmission that shouldn't exist in creatures without complex brains. The most unsettling observations come from the deepest trenches, where jellyfish behavior becomes increasingly alien. At depths exceeding 6,000 meters, researchers have documented jellyfish that appear to hibernate in groups, clustering together in cave-like formations for months at a time, before simultaneously emerging to engage in synchronized movement patterns across vast areas of the seafloor. These deep-dwelling populations also display what can only be described as mourning behavior. When a member of their group dies, the remaining jellyfish gather around the deceased individual, creating circular formations and pulsing their lights in slow, rhythmic patterns that can continue for days. This behavior has been documented across multiple species and locations, suggesting it's a fundamental aspect of deep-sea jellyfish psychology rather than a random occurrence. Perhaps most mysteriously, some deep-sea jellyfish populations appear to be growing more complex over time. Comparison of behavioral footage from the 1980s with recent observations suggests that certain deep-sea species are developing increasingly sophisticated behaviors. This apparent evolution of intelligence is happening on timescales that should be impossible, suggesting these ancient creatures might be adapting to the deep ocean environment in ways we're only beginning to understand. The implications of these discoveries extend far beyond marine biology. If creatures with the simplest nervous systems known to science can display complex behaviors, learning, and even culture when placed in extreme environments, what does this say about the nature of intelligence itself? The deep ocean may be teaching us that consciousness and complex behavior can emerge from biological systems we previously considered too simple to support such phenomena. As we continue to explore the deepest parts of our oceans, jellyfish populations continue to challenge our understanding of what's possible in the natural world. Their otherworldly behaviors remind us that Earth's most alien landscapes aren't found in distant galaxies, but in the crushing darkness of our own deep seas, where ancient creatures are rewriting the rules of biology in ways we're only just beginning to comprehend. The Enigma of Phantom Islands. In 1876, Captain Benjamin Morrell documented a pristine island in the South Pacific, complete with sandy beaches and lush vegetation. He recorded its exact coordinates, sketched its coastline, and named it New South Greenland. When subsequent expeditions arrived at those precise coordinates, they found nothing but empty ocean stretching to the horizon. Phantom Islands represent one of cartography's most unsettling mysteries. These are land masses that appeared on maritime charts for decades, sometimes centuries, only to vanish without explanation. Not metaphorically vanish, literally disappear from the face of the earth, leaving behind only aging maps and bewildered sailors' testimonies. The phenomenon extends far beyond simple navigational errors. We're examining cases where experienced mariners provided detailed descriptions, accurate coordinates, and even claimed to have set foot on solid ground. Yet when modern vessels arrive at these documented locations, sophisticated sonar reveals ocean depths of thousands of feet. Consider the island of Bermuda, once marked on Spanish colonial maps off the coast of Mexico's Yucatan Peninsula. This wasn't some vague notation. Spanish authorities used Bermuda as a reference point for territorial boundaries throughout the 16th and 17th centuries. Legal documents from that era specifically mention the island's strategic importance for defining maritime borders between Spanish and British territories. When Mexican officials attempted to locate Bermuda in the 1990s to support oil drilling claims, exhaustive searches turned up nothing. Satellite imagery showed no trace. Underwater surveys revealed a gradually sloping seabed with no evidence of recent geological activity that might explain a vanished landmass. The mystery deepens when we examine the sheer number of phantom islands documented throughout maritime history. Sandy Island appeared on charts of the Coral Sea for over a century. Described as roughly the size of Manhattan, it warranted inclusion on Google Earth until 2012, when an Australian research vessel sailed directly through the coordinates where the island supposedly existed. Marine geologist Dr. Sarah Chen investigated the Sandy Island case extensively. Her team's analysis revealed something peculiar in the historical records. Multiple independent sources had reported the island across different decades, describing similar features: white sandy beaches, low-lying terrain, and clusters of coconut palms. These accounts came from ships that had no contact with each other, making coordinated deception unlikely. What makes Phantom Islands particularly intriguing is their selective visibility. There are documented cases of ships failing to locate an island that another vessel had reported just weeks earlier. In 1823, the whaling ship Aurora reported discovering an island cluster in the South Atlantic, providing detailed coordinates and descriptions of the terrain. Captain James Weddell attempted to locate these Aurora Islands the following year, following the exact same route, but found only open water. The Aurora Islands case illustrates another puzzling aspect of Phantom Island encounters: the specificity of the reports. Captain Dirk Gerrits didn't simply claim to see land in the distance. He documented rocky coastlines, estimated the island's elevation at approximately 800 feet, and noted what appeared to be snow-covered peaks. His description was precise enough that subsequent expeditions could theoretically recognize the islands if they existed. Some researchers propose that phantom islands result from unusual atmospheric conditions that create convincing optical illusions. Superior mirages can project images of distant land masses across vast oceanic distances, creating the visual appearance of islands where none exist. However, this theory struggles to explain cases where sailors claim to have physically landed on phantom islands, collected specimens, and even established temporary camps. The island of Brazil offers perhaps the most perplexing example. Medieval maps consistently showed this circular island west of Ireland, and it maintained its position on navigation charts for over 500 years. Irish fishermen regularly reported sightings of Brazil, describing it as shrouded in mist, but clearly visible at certain times of day. Some accounts claim that individuals actually set foot on Brazil, describing stone beaches and ancient ruins. Captain John Nisbet documented the most detailed Brazil encounter in 1674. His ship's log describes landing on the island during a clearing fog and discovering 4 elderly men who claimed to be the island's only inhabitants. According to Nisbet's account, these men spoke an archaic form of Irish and insisted they had lived on Brazil for generations, sustained by hunting rabbits and collecting rainwater. Modern oceanographic surveys of the area where Brazil allegedly existed show consistent water depths of over 600 feet, with no underwater formations that might support such stories. Yet the reports persisted across centuries, coming from independent sources who had no apparent motive for fabrication. The Pacific Ocean contains its own collection of phantom islands, many documented by Russian and Japanese explorers. Ganges Island appeared on multiple 19th century charts north of the Hawaiian chain. Russian naval officer Adam Johann von Krusenstern provided coordinates and noted distinctive rock formations along the island's eastern shore. American and British expeditions that followed his route found no trace of land. Perhaps most unsettling are cases where phantom islands disappeared gradually rather than suddenly. Cartographers noticed that certain islands became increasingly difficult to locate over time, as if they were slowly sinking or dissolving. The island of Tuanaki, recorded in Polynesian oral traditions and early European maps, supposedly vanished beneath the waves sometime in the mid-19th century. Local islanders maintain that their ancestors had regular contact with Tuanaki's inhabitants until the island mysteriously submerged. Contemporary technology has largely eliminated new Phantom Island reports, but it hasn't resolved the historical mystery. Satellite coverage is comprehensive enough that previously unknown landmasses are quickly identified and verified. This makes the historical accounts more puzzling. Were earlier navigators experiencing phenomena that no longer occur, or were they documenting something that modern instruments cannot detect? The Phantom Island Enigma touches on fundamental questions about the reliability of human observation and the stability of our planet's geography. These aren't tales from superstitious sailors, they're documented reports from experienced navigators whose careers depended on accurate observations. Whatever caused Phantom Islands to appear on centuries of maritime charts remains unexplained, leaving us to wonder what other mysteries might be hidden in the vast expanses of our still largely unexplored oceans. Hydrothermal worm colonies. 2 miles beneath the Pacific's surface, where crushing pressure meets water hot enough to melt lead, scientists discovered something that challenged every assumption about what life requires to survive. In the scalding outflow of hydrothermal vents, where temperatures reach over 750 degrees Fahrenheit, vast colonies of tube worms thrive in numbers that dwarf entire rainforest ecosystems. These aren't ordinary creatures surviving harsh conditions. They're evolutionary masterpieces that have rewritten the fundamental rules of biology itself. The first glimpse came in 1977, when marine biologist Jack Corliss descended in the submersible Alvin toward the Galapagos Rift. The mission targeted unusual temperature readings detected by deep-sea sensors, readings that suggested volcanic activity on the ocean floor. What they found instead was a biological wonderland that shouldn't exist according to established science. Giant tube worms, some reaching 8 feet in length and as thick as a human arm, clustered around chimney-like structures belching superheated water. Their ghostly white tubes swayed in the mineral-rich currents, crowned with brilliant red plumes that moved like underwater flowers in an alien garden. The sight was so unexpected, so contrary to what marine biologists thought possible, that Corliss initially wondered if his equipment was malfunctioning. On Earth's surface, virtually all life depends on photosynthesis, plants converting sunlight into energy that flows through every food chain we know. But these worms exist in eternal darkness, where photosynthesis is impossible. They've evolved a completely different approach to survival, one that transforms poison into sustenance and death into life. The secret lies in their extraordinary partnership with bacteria. These tube worms, known scientifically as Riftia pachyptilla, have no mouth, no stomach, and no digestive system as we understand it. Instead, they house billions of chemosynthetic bacteria within specialized organs called trophosome tissues. These bacterial partners consume hydrogen sulfide, the same toxic gas that would kill most living things within minutes, and convert it into organic compounds that nourish their worm hosts. Dr. Colleen Kavanagh's groundbreaking research at Harvard revealed the precise mechanics of this impossible relationship. The worm's blood contains specialized hemoglobin that can transport both oxygen and hydrogen sulfide without the two chemicals destroying each other. This biological innovation allows them to deliver raw materials directly to their bacterial partners, who then manufacture nutrients from scratch in a process that generates no waste products. The implications stagger marine biologists. These worms grow faster than almost any other deep-sea creature, reaching full size in less than 2 years despite living in an environment that should inhibit biological processes. Their growth rates rival those of plants in tropical climates, yet they thrive in conditions more extreme than most volcanic environments on land. But perhaps most remarkably, these colonies appear and disappear according to geological rhythms that span decades. When hydrothermal vents become active, worm larvae somehow detect the chemical signatures from miles away and colonize the new sites within months. When vents go dormant, entire colonies vanish, leaving only empty tubes as evidence of their existence. Recent deep-sea explorations have revealed that these worm colonies exist in virtually every hydrothermal system discovered, from the mid-Atlantic ridge to the volcanic vents off Japan's coast. Each population has developed unique adaptations to local conditions, suggesting that this form of life has been evolving in isolation for millions of years. What troubles scientists most is how these creatures first evolved. The transition from conventional metabolism to chemosynthesis requires multiple simultaneous genetic changes, each of which would be lethal without the others. The mathematical probability of such coordinated mutations occurring naturally approaches impossibility. Yet these creatures clearly exist and flourish. Dr. Timothy Shank from Woods Hole Oceanographic Institution has documented colonies containing over 300,000 individual worms concentrated in areas smaller than a football field. The biomass density exceeds that of coral reefs, despite existing in conditions that would instantly sterilize most environments. These discoveries suggest that deep-sea hydrothermal systems may harbor more life than all surface ecosystems combined. The worm's longevity presents another puzzle. Individual specimens can live for over 300 years, their tubes growing continuously throughout their lifespans like underwater trees. Some colonies appear to be ancient, with carbon dating suggesting continuous occupation of certain vent sites for over 10,000 years. This longevity occurs despite the extreme chemical and thermal stress that should accelerate aging and cellular damage. Recent molecular analysis has revealed that these worms share genetic sequences with creatures from completely different evolutionary lineages, sequences that appear nowhere else in the animal kingdom. Some researchers theorize that horizontal gene transfer, the direct exchange of genetic material between unrelated species, may have played a role in their development, though this process has never been documented in complex animals. The colonies also exhibit collective behaviors that suggest a form of chemical communication. When one section of a colony detects changes in water chemistry or temperature, The entire population can respond within hours, adjusting their feeding positions and metabolic rates in coordinated patterns. This coordination occurs despite the fact that individual worms have no recognizable nervous system or brain structure. Perhaps most intriguingly, these worm colonies serve as sentinels for geological activity that occurs deep within Earth's crust. Their population booms and crashes correlate with seismic events that won't be detectable by human instruments for months or even years. Some marine geologists now monitor worm colony behavior as an early warning system for underwater volcanic activity. As we continue mapping the ocean floor, new colonies turn up in locations where the geology suggests hydrothermal activity should be impossible. These discoveries force us to reconsider, not just what we know about deep-sea life, but about the fundamental conditions that make life possible at all. These ancient colonies, thriving in their infernal gardens, represent more than just biological curiosities. They're proof that life finds ways to exist under conditions we never thought possible, and they may hold secrets about how life itself first emerged on our planet billions of years ago. Mysteries of the Sargasso Sea. There exists a sea within a sea, a place where the Atlantic Ocean holds its breath and keeps its secrets close. 2 million square miles of water, bound not by land but by invisible walls of current, spinning clockwise in an endless, ancient dance. The Portuguese mariners called it Mar de Sargasso, the Sea of Grapes, for the golden seaweed that carpets its surface like a living constellation. But beneath that deceptively pastoral name lies something far more enigmatic. The Sargasso Sea defies every rule we've written about oceans. Most seas touch shores. This one exists suspended in the middle of the Atlantic, held in place by 4 major currents that form a maritime prison of sorts. The Gulf Stream races along its western edge. The North Atlantic Current guards the north. The Canary Current flows down the east, and the North Atlantic Equatorial Current completes the circle to the south. Within these boundaries, the water moves differently, slowly, almost meditatively. Captain Christopher Columbus encountered these waters in 1492, and the entries in his ship's log grow increasingly uneasy as the days pass. His crew believed they were sailing into a field of meadows. That land must surely lie just ahead, but the seaweed stretched endlessly, and the wind simply stopped. For days, Columbus recorded an eerie stillness that left his sailors whispering of supernatural forces. They weren't entirely wrong. The sargassum seaweed that gives this sea its name exhibits behavior that marine biologists still struggle to explain fully. Unlike other seaweeds that grow anchored to the ocean floor, sargassum floats freely, reproducing vegetatively, creating what amounts to a self-sustaining floating ecosystem that may be thousands of years old. Some researchers propose that certain patches of this weed have been drifting in these same circular patterns since before the Roman Empire. A golden garden, ancient and untethered, but the seaweed is merely the beginning of the mysteries here. In 1968, marine biologist Dr. Sylvia Earle descended into the deeper waters of the Sargasso Sea and discovered something that challenged fundamental assumptions about ocean life. The region, despite appearing somewhat barren from the surface, supports an ecosystem unlike anywhere else on Earth. American and European eels, separated by an entire ocean, both migrate here to spawn. For decades, scientists couldn't explain how eels from completely different continents knew to converge on this exact location, or how their larvae knew to return to their respective home waters. The magnetic properties of the Sargasso Sea present another puzzle. Ships' compasses have reported unusual deviations here since the age of sail, and modern electronic navigation systems occasionally register anomalous readings. In 1975, the research vessel Atlantis II documented magnetic variations that seemed to follow no recognizable pattern, occurring in clusters that shifted location over periods of days or weeks. The ocean floor beneath the Sargasso Sea shows no unusual geological features that would explain these magnetic disturbances. Then there are the convergences, massive gatherings of marine life that occur without warning and dissolve just as mysteriously. In September of 1991, marine photographer David Fleetham was documenting turtle populations when he encountered what he later described as an underwater Times Square. Thousands of sea turtles, sharks, rays, and fish species had congregated in a relatively small area of the Sargasso Sea. swimming together in what appeared to be organized formations. When Fleetham returned to the same coordinates 3 days later, the ocean was empty. Marine biologists who reviewed his photographs could offer no conventional explanation for such a gathering. The water itself behaves strangely here. Sailors consistently report areas of unusual warmth that appear and disappear without corresponding to any known current patterns. These thermal anomalies, dubbed warm pockets by researchers, can span several miles and persist for weeks before vanishing entirely. Oceanographer Dr. James Morrison documented 17 such anomalies during a 3-month study in 1989, finding that water temperatures in these zones measured up to 15 degrees higher than surrounding areas, with no identifiable heat source. Perhaps most unsettling are the acoustic phenomena. The Sargasso Sea amplifies sound in ways that violate known principles of underwater acoustics. Underwater microphones deployed by the Woods Hole Oceanographic Institution have recorded what researchers term phantom echoes, sounds that appear to bounce off structures that don't exist. Sonar readings show clear, solid returns from empty water, as if invisible walls rise from the depths. Local folklore among the scattered islands of the western Atlantic speaks of the Sargasso Sea as a place where time moves differently. Bermuda fishermen, whose families have worked these waters for generations, tell stories of entering the seaweed fields and emerging hours later to find that entire days had passed. While such accounts resist scientific verification, they echo consistently across different island communities that have no regular contact with each other. The biological mysteries deepen with each research expedition. Species of fish thought extinct for millions of years occasionally surface in Sargasso waters. In 2003, marine biologist Dr. Elena Rodriguez captured and photographed a specimen that appeared to be a prehistoric lungfish, complete with primitive fin structures that shouldn't exist in modern oceans. By the time she returned to port, the specimen had deteriorated beyond genetic testing, leaving only photographs as evidence. Contemporary satellite imagery reveals another puzzle: periodic formations in the seaweed that appear almost geometric in nature. These patterns, visible only from high altitude, form rough circles, spirals, and occasionally straight lines stretching for miles. They emerge and dissolve over periods of days, as if the sea itself were writing messages in a language we don't recognize. The Sargasso Sea continues to resist our attempts at complete understanding. Its currents follow predictions until they don't. Its marine life adheres to known migration patterns except when entirely different rules seem to apply. It remains a place where the ordinary laws of oceanography bend, where ancient patterns persist, and where the boundary between the explicable and the impossible grows thin as kelp beneath the surface. In these suspended waters, somewhere between the familiar and the unknown, the ocean keeps its counsel, and we drift through its mysteries, searching for answers that seem always to float just beyond reach. The Titanic's silent guardians, 2 miles beneath the North Atlantic's surface, something peculiar guards the most famous shipwreck in history. Scientists studying the Titanic's remains have discovered that the great liner isn't simply rusting away in solitude, it's being slowly, deliberately consumed by microorganisms that shouldn't be able to survive at such depths. When Robert Ballard first glimpsed the Titanic's bow section in 1985, his team noticed something extraordinary: delicate, icicle-like formations draped from the ship's superstructure like frozen curtains. These weren't ice formations, they were living structures, built by bacteria that had claimed the wreck as their domain. The researchers nicknamed them rusticles, a combination of rust and icicles. But these formations represent something far more complex than simple corrosion. Dr. Henrietta Mann, a microbiologist at Dalhousie University, has spent years studying samples from these rusticles. What she discovered challenges our understanding of life in the deep ocean. The bacteria consuming the Titanic, which she named Halomonas titanica, can survive crushing pressures that would instantly kill most surface organisms. They've evolved specifically to feed on the iron-rich environment of the shipwreck, creating a unique ecosystem that exists nowhere else on Earth. These microscopic guardians work with methodical precision. They don't randomly attack the metal, they follow specific patterns, consuming the ship's structure from the inside out. The bacteria form complex communities, with different species performing different functions. Some break down the iron, Others process the resulting compounds, and still others maintain the delicate rustical structures that house their colonies. What's particularly fascinating is how these organisms have adapted to their environment in just over a century. When the Titanic sank in 1912, these bacteria didn't exist in this form. They evolved specifically to take advantage of the massive iron buffet that had suddenly appeared in their world. This represents one of the fastest documented cases of bacterial evolution in response to a new environmental opportunity. The rusticles themselves are architectural marvels. Each formation contains millions of bacterial cells arranged in complex networks. Water flows through these structures like blood through arteries, carrying nutrients and oxygen to the deepest parts of the colony. The bacteria have essentially turned the Titanic into a living reef, complete with its own circulatory system. But here's where the story becomes truly remarkable. These bacterial communities aren't just consuming the ship, they're protecting it in their own way. The rusticles form a barrier between the metal and the corrosive seawater, actually slowing the overall decay process in some areas. It's as if the bacteria understand that destroying their home too quickly would eliminate their food source. They've achieved a delicate balance between consumption and preservation. Marine archaeologists estimate that at the current rate of bacterial consumption, the Titanic's hull will completely collapse within the next few decades. But this isn't destruction, it's transformation. The bacteria are converting the ship's iron into new compounds, creating minerals that will eventually become part of the ocean floor. In effect, they're recycling one of humanity's greatest engineering achievements back into the natural world. The implications extend far beyond one shipwreck. Scientists have found similar bacterial communities on other deep-sea wrecks, suggesting that this process might be a universal response to large iron deposits on the ocean floor. These microorganisms might play a crucial role in the ocean's chemistry, processing metals and minerals in ways we're only beginning to understand. Recent expeditions have revealed that the bacterial communities around the Titanic are becoming increasingly complex. New species continue to evolve, each finding its own niche within the wreck's ecosystem. Some bacteria have been found living inside the ship's original electrical systems, feeding on copper wiring. Others have colonized the brass fixtures, breaking down different metals entirely. The bacteria have also attracted other deep-sea life. Fish use the rusticles as shelter, and small crustaceans graze on the bacterial mats like underwater cattle. The Titanic has become an oasis of life in the deep ocean desert, all thanks to these microscopic guardians that first claimed it as their own. Perhaps most intriguingly, these bacteria might hold clues to life beyond Earth. Their ability to thrive in extreme conditions, crushing pressure, near freezing temperatures, and complete darkness, mirrors the environments scientists believe might exist on other planets. If life can flourish in such harsh conditions around the Titanic, it might also exist in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus. Dr. Man's team has discovered that the bacteria communicate with each other through chemical signals, coordinating their consumption of the ship like a vast, distributed intelligence. When one area of the wreck becomes depleted of nutrients, the bacterial communities shift their focus to richer feeding grounds. They're essentially farming the Titanic, managing their resource to ensure long-term survival. The temperature around the wreck plays a crucial role in this process. The deep ocean's near-freezing temperatures slow the bacteria's metabolism, allowing them to work at a measured pace. If the wreck existed in warmer waters, the bacterial consumption would accelerate dramatically, potentially dissolving the ship within years instead of decades. As we continue to study these silent guardians, they're teaching us profound lessons about resilience, adaptation, and the interconnectedness of life. The Titanic's tragedy has become the foundation for an entirely new ecosystem, one that demonstrates life's remarkable ability to find opportunity even in the depths of disaster. The bacteria consuming the Titanic represent more than just marine biology. They're a reminder that nothing in nature is permanent, and that what we consider endings might simply be new beginnings in disguise. In the crushing darkness of the deep Atlantic, these microscopic guardians continue their patient work, transforming monument into memory, metal into life, ensuring that even in its final chapter, the Titanic continues to surprise us. Strange discoveries at the Antarctic bottom. In 2019, researchers drilling through nearly half a mile of Antarctic ice made a discovery that fundamentally challenged what we thought we knew about life on Earth. What they found clinging to a rock the size of a coffee table, in complete darkness, in sub-zero temperatures, with no obvious food source, shouldn't have been there. Yet there it was, thriving. The Antarctic seafloor represents one of Earth's most extreme environments. Picture water so cold it should theoretically be solid, crushed under ice sheets that have pressed down for millions of years, in darkness so complete that no photosynthesis has occurred there since the continent drifted to its current position. This isn't just inhospitable. This is a world that seems designed to prevent life from taking hold. Dr. Hugh Griffiths from the British Antarctic Survey was part of the team that made this discovery. When they pulled up their sampling equipment, they expected to find barren rock, maybe some bacterial films if they were lucky. Instead, they found sponges. Not just any sponges, but species that appeared to be thriving in conditions that would kill most life forms within minutes. The implications hit the scientific community like a seismic wave. These weren't just any organisms clinging to survival. These were complex, multicellular life forms that had somehow established an entire ecosystem in what should have been a biological dead zone. The sponges weren't alone either. Alongside them, researchers identified what appeared to be stalked organisms, possibly some form of sea anemone or coral, creatures that typically require energy from above to survive. But here's where the mystery deepens. These organisms were found 160 miles from the nearest edge of the ice shelf. That's 160 miles from the nearest possible source of sunlight-derived nutrition. In traditional marine ecosystems, life forms this far from photosynthetic zones rely on what's called marine snow, the gentle drift of organic matter that falls from surface waters. Under the Antarctic ice sheet, there is no marine snow. There is no obvious energy source at all. The research team faced a puzzle that challenged fundamental assumptions about how life sustains itself in extreme environments. Dr. Griffiths and his colleagues had to completely rethink what they thought they knew about Antarctic marine biology. The discovery forced them to ask uncomfortable questions about what other life might be thriving in places we've written off as lifeless. As word of the discovery spread through the scientific community, it became clear this wasn't an isolated incident. Other research teams began reporting similar findings. In 2021, researchers from Germany's Alfred Wegener Institute discovered bacterial mats covering vast areas of the Antarctic seafloor, some containing species that had never been cataloged before. These weren't just bacterial films either. They were complex, organized communities that appeared to have sophisticated methods of energy production and waste management. The deeper researchers looked, the more questions emerged. Some of the organisms they found appeared to be ancient, possibly representing evolutionary lines that had been cut off from the rest of the planet for millions of years. Others seemed to be actively evolving, adapting to their environment in ways that suggested rapid genetic changes. One particularly intriguing discovery came from submersible footage captured beneath the Ross ice shelf. The cameras revealed what appeared to be tube worms, similar to those found around deep-sea hydrothermal vents, but with one crucial difference. These tube worms were thriving in areas with no detected thermal activity. They seemed to be deriving energy from chemical processes that researchers couldn't identify. The footage showed something else that gave researchers pause. The seafloor wasn't uniform. There were areas that appeared to be meticulously organized, almost cultivated. Some scientists began using the term gardens to describe sections where different species seemed to be arranged in patterns that suggested intentional placement rather than random distribution. Dr. Craig Stevens, a marine physicist who has studied Antarctic waters for over 2 decades, described the findings as fundamentally unsettling, not because they were dangerous, but because they suggested that life was far more resilient and resourceful than previously imagined. If complex organisms could thrive in these conditions, what did that mean for our understanding of where life might exist elsewhere in the universe? The discovery also raised questions about how long these ecosystems had been developing. Some of the organisms showed signs of being incredibly old, potentially representing unbroken evolutionary lines stretching back millions of years. Others appeared to be relatively recent arrivals, somehow finding their way to the Antarctic seafloor and establishing themselves despite the seemingly impossible conditions. Perhaps most intriguingly, some of the organisms displayed characteristics that seemed almost designed for their environment. Certain species of sponges showed internal structures that appeared to maximize energy extraction from the minimal nutrients available. Others had developed what looked like cooperative relationships with bacterial communities, creating mini ecosystems within their own bodies. The research teams also found evidence of what they termed biological highways, pathways along the seafloor, where different species seemed to be connected by networks of organic material. These networks appeared to be facilitating the exchange of nutrients and possibly information between distant communities of organisms. As scientists continue to study these discoveries, they're being forced to reconsider fundamental assumptions about the limits of life on Earth. The Antarctic seafloor findings suggest that life might be far more widespread and adaptable than we previously believed. If organisms can thrive in the crushing darkness beneath miles of ice, consuming energy from sources we can barely detect, what other impossible places might be teeming with life? The research continues, but each new discovery seems to raise more questions than it answers. The Antarctic seafloor has become more than a scientific curiosity. It's become a window into possibilities we're only beginning to understand, and a reminder that even in the most seemingly lifeless places on Earth, life finds a way to surprise us. The oracle fish of ancient seas. For centuries, fishermen returning to Mediterranean ports carried tales that defied rational explanation. They spoke of encounters with creatures that seemed to know things no fish should know. Ancient Greek sailors swore by the prophetic powers of certain deep-dwelling species, claiming these fish would surface only before significant events. Roman chroniclers documented similar accounts from across their maritime empire. The stories follow a pattern too consistent to dismiss entirely. In 79 AD, just days before Mount Vesuvius erupted, fishing crews near Pompeii reported massive schools of deep-sea fish rising to shallow waters, species never seen at such depths. The fish exhibited strange behaviors, swimming in perfect geometric formations before diving back into the abyss. Similar reports emerged before the great earthquake that devastated Antioch in 115 AD. But these weren't isolated incidents confined to antiquity. Modern marine biologists have begun documenting what they term anomalous fish behavior preceding seismic events. Dr. Elena Vasquez, studying Mediterranean fishing records spanning 8 centuries, discovered something remarkable. In 847 documented cases of unusual deep-sea fish surfacing, 783 occurred within 2 weeks of major geological events, earthquakes, volcanic eruptions, or underwater landslides. The statistics troubled her research team. We're looking at behavioral patterns that suggest these creatures possess sensory capabilities we don't understand, Vasquez noted in her 2019 study. The correlation isn't coincidental. These fish are responding to environmental changes we can't detect with our instruments. The ancient Greeks called them mantes ichthys, prophet fish. They believed certain species carried messages from Poseidon himself, warnings of disasters or promises of favorable conditions. Aristotle, ever the skeptic, dismissed such notions as superstition. Yet his own writings reveal an uncomfortable truth. He couldn't explain why deep-sea species repeatedly surfaced before catastrophic events. Archaeological evidence supports the historical accounts. Stone tablets recovered from submerged ruins near Crete describe elaborate rituals surrounding the appearance of messenger fish from the depths. These ceremonies weren't casual traditions. They represented sophisticated early warning systems that coastal communities relied upon for survival. The tablets detail specific species, large silver-scaled fish with prominent eyes, creatures that normally inhabited depths beyond human reach. When these fish appeared in shallow waters, exhibiting unusual swimming patterns, entire villages would prepare for disaster. The preparation protocols were remarkably detailed, suggesting generations of refined observation. Contemporary research has identified several candidates for these legendary oracle fish. The oarfish, reaching lengths of 30 feet, typically dwells at depths of 650 to 3,000 feet. In Japanese folklore, this serpentine creature is called Ryugu no Tsukai, messenger from the sea god's palace. Before the 2011 tsunami that devastated Japan's coast, dozens of oarfish washed ashore across the region. Local fishing communities noted their appearance with traditional dread. The deep-sea hatchetfish presents another compelling case. These creatures possess highly sensitive lateral line systems that detect subtle pressure changes in their environment. Dr. James Chen, a marine seismologist at Woods Hole, has been studying their behavioral patterns in relation to underwater seismic activity. Hatchetfish respond to pressure variations we can barely measure, Chen explained during a 2020 conference. They're essentially living barometers, capable of sensing tectonic stress building along fault lines. When they rise to escape these pressure changes, they're inadvertently warning us of impending geological events. Ancient texts from various cultures describe similar phenomena. Norse sagas speak of wisdom fish that surfaced before storms. Polynesian navigation traditions include references to deep-sea creatures whose appearance guided voyagers away from dangerous waters. Chinese maritime records from the Tang Dynasty document dragonfish that preceded underwater earthquakes by days. The scientific explanation remains elusive. Fish lack the complex nervous systems required for true precognition, yet their behavior suggests access to environmental information unavailable to human senses. Some researchers propose that these creatures detect infrasound, low-frequency vibrations produced by geological processes, long before seismic events become apparent through conventional monitoring. Dr. Maria Santos, studying fish behavior patterns off the Portuguese coast, has recorded several instances of mass deep-sea surfacing events that preceded underwater landslides. Her hydrophone arrays detected unusual low-frequency signals in the days leading up to these fish migrations, sounds that seem to originate from deep ocean trenches. The fish aren't prophetic, Santos clarified. They're responding to real physical phenomena that we're only beginning to understand. Their sensory capabilities have evolved over millions of years to detect subtle environmental changes that indicate danger. The implications extend beyond marine biology. If these fish possess early warning capabilities, understanding their behavior could revolutionize disaster prediction. Current seismic monitoring relies on detecting movement along fault lines. By then, an earthquake is imminent or already occurring. Fish behavior might provide weeks of advance warning, yet skeptics remain justified in their caution. Correlation doesn't establish causation, and the historical record contains numerous instances of unusual fish behavior that produced no corresponding disasters. The challenge lies in distinguishing genuine precursory behavior from normal deep-sea migrations, feeding patterns, or responses to other environmental factors. Ancient mariners understood this limitation. They developed complex systems for interpreting fish behavior, considering factors like species, location, timing, and accompanying environmental conditions. These weren't simple superstitions, but sophisticated observational frameworks refined across generations. The oracle fish phenomenon represents something deeper than folklore. It suggests that nature possesses early warning systems we've barely begun to comprehend. These creatures navigate a world of pressure, sound, and electromagnetic fields, largely invisible to human perception. Their behavior patterns, encoded in centuries of maritime tradition, may contain scientific insights we're only now equipped to investigate. Modern technology allows us to study these ancient mysteries with unprecedented precision. Satellite tracking, genetic analysis, and advanced acoustic monitoring provide tools the Greeks could never imagine. Yet the fundamental questions persist. Do these fish truly possess prophetic abilities, or are they simply more attuned to their environment than we ever suspected? The answer may lie somewhere between ancient wisdom and modern science, in the depths where legend and biology converge. Underwater mud volcano mysteries. Deep beneath the Black Sea, something stirs, not the familiar rumble of tectonic plates or the gentle sway of currents, but something far more ancient, a slow, methodical pulse that pushes through the seafloor itself, reshaping the ocean bottom one eruption at a time. Marine geologist Dr. Elena Vasquez first witnessed this phenomenon during a routine mapping expedition in 2019. Her sonar readings showed what appeared to be a mountain where her charts indicated flat seabed. When she returned 3 months later, the mountain had shifted, not collapsed or eroded, shifted, as if the seafloor itself was breathing. What she discovered was something science is still struggling to fully comprehend: underwater mud volcanoes that seem to operate by rules we don't entirely understand. Unlike their fiery terrestrial cousins, these underwater formations don't spew molten rock. Instead, they belch forth a cocktail of sediment, water, and gases that have been trapped in Earth's crust for millions of years. The mixture emerges at temperatures barely above freezing, yet it carries with it fragments of our planet's deepest secrets. The mechanics should be straightforward. Pressurized fluids beneath the seafloor find weak points in the sediment layers and force their way upward. The expelled material builds cone-shaped structures that can tower hundreds of meters above the surrounding seabed. Simple geology, observable and measurable. But the reality proves far more complex. Dr. Vasquez's team documented mud volcano eruptions that occurred in perfect synchronization across distances of over 200 kilometers. These formations had no apparent geological connection, no shared fault lines or pressure sources, yet they activated within hours of each other, as if responding to some signal science cannot detect. The expelled material itself presents another puzzle. Chemical analysis reveals sediments that predate the surrounding ocean floor by tens of millions of years. Somehow, these volcanoes are reaching into geological layers that shouldn't exist at their locations, pulling up remnants of ancient seafloors that were supposedly consumed by tectonic activity eons ago. Romanian researchers studying mud volcanoes in the Black Sea found something even more perplexing. The expelled sediments contained microscopic structures that resembled primitive cellular formations, not fossils exactly, but organized arrangements of minerals and organic compounds that seemed to mirror the architecture of early life forms. When they attempted to date these structures, the results defied explanation. The mineral components suggested ages consistent with the surrounding ancient sediments, yet the organic elements appeared far younger, as if something had been preserved in those deep layers, maintaining a form of chemical activity for geological time periods. The implications troubled the research team enough that they've spent 4 years attempting to replicate their findings before publishing. Each new sample yields similar results. Ancient minerals housing organic compounds that shouldn't exist. Beyond the Black Sea, underwater mud volcanoes have been documented in over 40 locations worldwide. The Mediterranean harbors dozens of active formations, some large enough to pose navigation hazards. The Gulf of Mexico hosts underwater mud volcano fields that stretch across thousands of square kilometers. Each location presents its own variations on the same impossible theme. In the Caspian Sea, mud volcanoes erupt with such regularity that local fishing communities have incorporated them into their traditional calendars. The formations follow cycles that align more closely with astronomical events than geological ones. During certain lunar phases, eruption activity increases by factors that statistical models cannot account for through tidal forces alone. Seismic monitoring of these events reveals another anomaly. The vibrations generated by underwater mud volcano eruptions don't match the expected signatures of fluid and sediment movement. Instead, they produce complex harmonic patterns that some researchers describe as almost musical in their mathematical precision. Dr. James Chen, who studies underwater acoustics at the Woods Hole Oceanographic Institution, recorded these seismic signatures across multiple eruption events. When he converted the data to audio frequencies, the patterns exhibited characteristics typically associated with biological communication rather than geological processes. The formations themselves defy conventional understanding of seafloor stability. Underwater mud volcanoes can grow from nothing to substantial geographic features in a matter of decades. They reshape entire sections of ocean floor, creating new topographies that affect current patterns and marine ecosystems. Yet they also disappear with equal unpredictability. Satellite bathymetry data shows mud volcano formations that vanished completely between survey periods, leaving no trace of their former presence. The seafloor simply returned to its original configuration, as if the temporary mountains had never existed. The expelled gases present their own mysteries. While most underwater mud volcanoes release predictable combinations of methane and hydrogen sulfide, some formations emit gas mixtures that include compounds typically associated with much deeper crustal layers. Helium isotopes that should only exist near the planet's core. Xenon concentrations that suggest interaction with materials from Earth's earliest formation period. These deep gases sometimes carry with them traces of metals and minerals that exist nowhere else in the surrounding geology. Rare earth elements in combinations that don't match any known terrestrial sources, as if the mud volcanoes are accessing reservoirs of material that predate our current understanding of planetary formation. Marine biologists studying the areas around active mud volcanoes have documented ecosystems that thrive in ways that challenge established models of deep-sea life. Colonies of organisms that seem perfectly adapted to the chemical conditions created by the eruptions, despite those conditions being temporary and unpredictable. These creatures don't simply tolerate the harsh environment around the mud volcanoes. They appear to depend on it in ways that suggest evolutionary relationships spanning far longer time periods than the formations themselves are believed to exist. The question that haunts researchers is whether underwater mud volcanoes are simply geological curiosities or windows into processes that shaped our planet in ways we haven't recognized. The ancient sediments, the synchronized eruptions, the impossible organic compounds all suggest that these formations might be accessing systems within Earth that operate on timescales and through mechanisms our current science doesn't acknowledge. Each new expedition yields more questions than answers. Each analysis reveals additional layers of complexity that seem to recede further the closer we look. The mud volcanoes continue their slow, methodical work far beneath the waves, reshaping the hidden landscape according to patterns we're only beginning to glimpse. Polychaete worm riddles. Marine biologist Dr. Elena Rodriguez spent 3 decades studying worms, yet nothing prepared her for what emerged from the abyssal depths in 2019. The creature that appeared on her research vessel's sampling net defied every classification system she knew. Its body twisted through colors that shouldn't exist at crushing depths where sunlight has never touched, sporting appendages that seemed to serve no evolutionary purpose she could identify. Polychaete worms inhabit every corner of our oceans, from shallow tide pools to the deepest trenches on Earth. We've cataloged over 10,000 species, yet deep-sea expeditions continue pulling up specimens that challenge our understanding of what's possible in the evolutionary tree. These aren't simple earthworms lost at sea. They're complex organisms displaying behaviors and adaptations that seem to operate by different biological rules entirely. The Pompeii worm thrives at temperatures that would instantly kill most life forms, building its home directly on hydrothermal vents, where water reaches 176 degrees Fahrenheit. Its survival strategy involves cultivating a coat of bacteria that somehow shields it from the scalding environment. When researchers first discovered these creatures in 1982, the leading marine biologist on the expedition described them as impossible animals living in an impossible place. But temperature tolerance represents just one puzzle among many. In the Mariana Trench, scientists have documented polychaete worms that appear to communicate through bioluminescent patterns. Their bodies pulse with coordinated light sequences across vast distances, creating what researchers describe as underwater constellation networks. The purpose remains completely unknown. No other deep-sea species demonstrates this type of organized light communication at such depths. Dr. Sarah Chen's research team at the Woods Hole Oceanographic Institution has spent the last 5 years tracking these luminescent conversations. Her data reveals patterns that repeat across different trenches, suggesting some form of standardized language. We're observing what appears to be information transfer, she explains in her 2023 research notes, but the content and purpose elude us completely. Even more perplexing are the architectural achievements of certain deep-sea polychaetes. The Japanese research vessel Yokosuka documented massive structures in the Japan Trench that initially appeared to be geological formations. Closer examination revealed them as elaborate constructions built entirely by polychaete worms. These aren't simple burrows or basic shelters. They're complex multi-chambered systems spanning hundreds of meters, featuring sophisticated ventilation networks and drainage systems that would impress human engineers. The construction process itself defies explanation. Individual worms, each measuring only a few centimeters, somehow coordinate to build structures requiring thousands of participants working in perfect synchronization. No known communication system could facilitate this level of organization among creatures previously thought to operate purely on instinct. French marine researcher Dr. Philippe Dubois captured time-lapse footage of this construction process during a 2022 expedition near the Mid-Atlantic Ridge. His videos show worms arriving at construction sites from various directions, each seeming to know exactly where their contribution fits within the larger design. It's like watching a symphony orchestra, where every musician knows their part without a conductor, he observed in his expedition logs. The reproductive strategies of deep-sea polychaetates present another biological enigma. Traditional polychaetate reproduction follows predictable patterns linked to lunar cycles and seasonal changes. Deep-sea species appear to coordinate reproduction across entire ocean basins simultaneously, despite being separated by thousands of miles and having no apparent method of long-distance communication. In March 2021, research stations across the Pacific simultaneously documented mass reproduction events among deep-sea polychaetes. The synchronization occurred across species that had never been observed interacting, spanning from the Aleutian Trench to the Peru-Chile Trench. The mathematical probability of this occurring randomly approaches zero. Yet no mechanism has been identified that could coordinate such widespread biological timing. Dr. Michael Harrison's genetic analysis of deep-sea polychaete specimens has revealed another troubling pattern. These creatures display genetic diversity that should require millions of years to develop, yet carbon dating of their habitat sediments suggests they've occupied these environments for only thousands of years. Either our understanding of evolutionary timelines is fundamentally flawed, or these organisms are adapting and diversifying at rates that shouldn't be biologically possible. The metabolic capabilities of deep-sea polychaetes challenge our understanding of energy requirements for complex life. At crushing depths where organic matter is scarce, these creatures maintain not just survival but elaborate social behaviors, construction projects, and reproductive cycles that should require far more energy than their environment can provide. Some species appear to derive energy from chemical processes that remain unidentified, while others seem to operate at metabolic efficiencies that approach theoretical maximums. Recent discoveries have uncovered polychaete species that appear to modify their own genetics in response to environmental pressures. Real-time genetic adaptation was previously thought impossible in complex organisms, yet deep-sea polychaetes demonstrate this capability routinely. They're essentially rewriting their own biological code as conditions change, a process that should take countless generations but instead occurs within individual lifespans. The implications extend beyond marine biology. If these creatures have developed technologies, for lack of a better term, that allow unprecedented environmental adaptation, genetic modification, and coordinated construction, what other capabilities might exist in the deep ocean? Each expedition returns with evidence that our planet's most extreme environments harbor life forms operating by biological principles we're only beginning to glimpse. Dr. Rodriguez continues her research, though she admits the questions multiply faster than the answers. The polychaete worms of the deep sea represent more than unusual species in an extreme environment. They suggest that life itself may be far more sophisticated and mysterious than our current scientific frameworks can accommodate. Perhaps the most unsettling realization is how little we actually know about the creatures that share our planet, especially those dwelling in the vast unexplored regions beneath the waves. The cursed treasure of the sea. Gold has a peculiar relationship with water. While most metals surrender to the sea's corrosive embrace, gold endures, unchanged, untarnished, waiting. But what if that endurance comes at a price? What if the ocean's most coveted treasures carry with them something far more dangerous than their weight in precious metal? The waters off Nova Scotia hold secrets that have claimed more lives than any pirate's blade ever could. Here, beneath 2.5 miles of crushing darkness, lies the SS Central America, a steamship that vanished into a hurricane's fury in 1857, taking with her 3 tons of California gold and 425 souls. When treasure hunters finally located her remains in 1988, they discovered something that would haunt their dreams for decades to come. Tommy Thompson, the marine engineer who led the expedition, became the first person in modern history to recover gold from the infamous Ship of Gold. The initial recovery yielded coins and ingots worth millions, each piece emerging from the depths as pristine as the day it sank. Thompson's team celebrated their triumph, but their joy would prove tragically short-lived. Within months of the first recovery, Thompson's life began to unravel. Legal battles consumed his fortune, investors turned against him, and paranoia gripped his mind like a vice. By 2012, he had fled to Florida, living as a fugitive under assumed names. When authorities finally caught him, Thompson claimed he couldn't remember where he had hidden the recovered gold. The man who had conquered the ocean's depths could no longer navigate his own memories. Thompson's story isn't unique. The curse of ocean treasure has followed countless seekers into madness. bankruptcy, and death. Consider the fate of those who sought the treasure of the Nuestra Señora de Atocha, sunk off the Florida Keys in 1622. Mel Fisher spent 16 years searching for the Spanish galleon, watching his eldest son die in a diving accident during the hunt. When Fisher finally located the wreck in 1985, the discovery brought him fame and fortune, but it also triggered a legal nightmare that consumed his family for decades. The ocean, it seems, demands a price for its gold that goes far beyond the technical challenges of deep-sea recovery. Dive teams report strange phenomena around treasure sites that defy explanation. Equipment failures occur at rates that statisticians call impossible. Experienced divers become disoriented in ways that have nothing to do with nitrogen narcosis or pressure sickness. In 1990, a team investigating the wreck of the merchant vessel SS Geiersapa, torpedoed by German U-boats in 1941, reported encounters that left veteran salvage operators questioning their sanity. The ship carried 200 tons of silver, then the largest precious metal cargo ever lost at sea. Divers described shadows moving independently of light sources, tools that would function perfectly on the surface, but fail mysteriously at depth, and an overwhelming sense of being watched by unseen presences. Dr. Sarah Voss, a marine archaeologist from Woods Hole Oceanographic Institution, has spent 2 decades studying what she calls treasure site anomalies. Her research reveals patterns that extend far beyond psychological explanation. Ships carrying precious metals show signs of preservation that shouldn't exist, she explains. We find organic materials, wood, leather, even human remains, in states of preservation that contradict everything we know about deep-sea decomposition. The Spanish treasure fleet of 1715 offers perhaps the most documented case of oceanic curse. When 11 ships loaded with New World gold sank during a hurricane off Florida's coast, they created what modern treasure hunters call the graveyard of the Spanish Main. Every major expedition to recover the 1715 fleet has ended in tragedy, bankruptcy, or mysterious disappearance. Kip Wagner, who spent 30 years hunting the 1715 wrecks, documented over 200 impossible equipment failures, including compass needles that spun wildly near treasure sites and metal detectors that registered anomalous readings even when removed from the water. Wagner's journals, published posthumously, describe a growing conviction that the treasure itself actively resisted recovery. The phenomenon isn't limited to shipwrecks from the age of sail. Modern vessels carrying precious cargo show similar patterns. The SS Port Nicholson, sunk by Japanese submarines in 1942 while carrying a secret cargo of platinum, has claimed the lives of 7 divers in recovery attempts. Each death occurred under circumstances that defied standard diving safety protocols, leading insurance companies to classify the wreck as unsurveyable. Recent advances in deep-sea robotics have allowed researchers to observe treasure sites without risking human lives, but the anomalies persist. Remotely operated vehicles experience systematic failures when approaching precious metal cargoes. Camera systems that function flawlessly elsewhere produce distorted images near treasure sites. Sonar readings become erratic, showing depth measurements that shift without explanation. Dr. Marcus Webb, an oceanographer who has consulted on dozens of treasure recovery operations, proposes that precious metals may interact with seawater in ways that current science doesn't fully understand. Gold and silver are excellent conductors, he notes. When you concentrate tons of precious metal in a small area of ocean floor, you create electrical fields that could theoretically affect sensitive equipment. But that doesn't explain the psychological effects reported by dive teams. The psychological component of treasure curse deserves particular attention. Divers report shared hallucinations, collective dreams, and group experiences that suggest something beyond individual psychology. Teams investigating the same wreck, working different shifts, report identical visions of figures in period clothing moving through the wreckage. Perhaps most disturbing are the accounts of successful treasure hunters who describe feeling followed by their discoveries. Objects recovered from cursed wrecks seem to bring with them an atmosphere of unease that affects not just the finders, but everyone who comes into contact with the treasure. Museums have documented unexplained temperature drops in rooms housing recovered gold, while private collectors report persistent nightmares and feelings of being watched. The ocean holds its treasures for reasons that extend beyond simple physics. Gold may be imperishable, but the human cost of recovering it from the depths, suggests that some fortunes are meant to remain forever beyond our reach. In the crushing darkness of the deep sea, perhaps the greatest treasure is knowing when to leave well enough alone. The next time you hear of another treasure recovery expedition, remember Tommy Thompson, still unable to recall where he hid his golden prize. Some curses are worth more than their weight in gold. The Bermuda Triangle's deep caverns. When marine geologist Dr. Elena Vasquez descended in the submersible Deep Current to 8,400 feet below the Bermuda Triangle in September 2019, she expected to document standard limestone formations. What her cameras captured instead were cavern systems so vast and geometrically precise that her initial report was classified by the Naval Oceanographic Office for 6 months. The seafloor beneath this notorious stretch of ocean isn't the flat, sedimentary plain that appears on most nautical charts. It's a honeycomb of chambers, tunnels, and vertical shafts that plunge deeper than current technology can measure. Some of these caverns span several city blocks in diameter. Others form narrow corridors that stretch for miles, their walls carved with what appears to be mathematical precision. Dr. Vasquez's team mapped over 47 distinct cavern entrances in a 12-square-mile area. The formations don't match typical underwater erosion patterns, where normal ocean caves show the irregular wear of millennia of current flow. These chambers maintain sharp angles and smooth surfaces that seem almost engineered. The discovery gained urgency when researchers cross-referenced the cavern locations with historical disappearances. Of the documented aircraft and vessel incidents in the Bermuda Triangle since 1945, 73% occurred directly above major cavern systems. The correlation was too striking to dismiss as coincidence. Sonar readings from these depths reveal something even more puzzling. The caverns don't simply burrow into the seafloor. They appear to form an interconnected network stretching across hundreds of miles of ocean floor. Sound waves transmitted into one cavern have been detected emerging from systems over 60 miles away, suggesting a vast subterranean maze beneath the triangle's waters. Marine biologist Dr. James Crenshaw joined the research effort in 2020, drawn by reports of unusual water temperatures around the cavern entrances. His instruments recorded thermal variations that defied explanation. While the surrounding deep water held steady at 39 degrees Fahrenheit, temperatures near the cavern mouths fluctuated wildly, sometimes reaching 68 degrees, other times dropping to near freezing levels within minutes. These temperature shifts coincide with what locals call the breathing, a phenomenon known to Bahamian fishermen for generations but never officially documented. Every 6 hours and 17 minutes, powerful currents surge from the cavern entrances, creating updrafts strong enough to affect surface conditions hundreds of feet above. The timing is so precise that some fishing communities have set their schedules around these underwater tidal events. The currents carry more than just temperature variations. Water samples collected during these surges contain mineral compositions that don't match the surrounding ocean chemistry. High concentrations of rare earth elements, particularly neodymium and europium, appear in levels typically found only in deep mantle rock. How these materials reach the surface through limestone caverns remains unexplained. More intriguing are the electromagnetic readings. Dr. Sarah Chen's 2021 magnetometer survey detected powerful magnetic field distortions emanating from the largest cavern systems. These fields pulse in regular patterns. Every 43 seconds, a magnetic spike occurs that temporarily overwhelms sensitive navigation equipment. The pulses are strong enough to affect compass readings on vessels passing overhead. Aircraft pilots have reported similar phenomena for decades. Captain Maria Santos, a veteran commercial pilot with 28 years of experience flying Caribbean routes, described her encounter with what flight logs call compass deviations while crossing the triangle in 2018. Her instruments showed magnetic north shifting by 37 degrees in a matter of seconds, precisely above what researchers now know to be the largest mapped cavern system. The geometric precision of these formations raises uncomfortable questions about their origins. Underwater architect Dr. Michael Hernandez spent 2 years analyzing the structural patterns. His computer models suggest the caverns follow a mathematical sequence, each major chamber positioned at coordinates that form a complex geometric pattern when viewed from above. The probability of natural erosion creating such precise positioning is, according to his calculations, negligible. Ancient limestone can explain the material composition, but not the architectural consistency. These chambers show evidence of being carved, not eroded. Tool marks, if that's what they are, run in parallel lines along chamber walls. Some sections display what appears to be deliberate engineering, including supportive buttresses and drainage channels that direct water flow with remarkable efficiency. The age of these formations presents another puzzle. Core samples from cavern walls show limestone dating back 12,000 years, but the carving patterns cut through rock layers of different geological periods. Either the caverns were created over millions of years by an unknown process, or they were carved more recently by forces capable of cutting through stone as if it were soft clay. Local maritime records add another dimension to the mystery. Bahamian archives contain references to the breathing caves dating back to the 1600s. Spanish colonial documents describe unexplained compass failures and mysterious currents in the exact locations where modern researchers have mapped the largest cavern systems. These historical accounts remained largely ignored until recent discoveries gave them new significance. The cavern's potential connection to the Bermuda Triangle's reputation becomes clearer when examining the electromagnetic pulse patterns. The 43-second cycle corresponds with many reported instrument malfunctions. Radio communications become unreliable during these pulses, GPS systems show position errors, and electromagnetic compass readings shift unpredictably. Dr. Vasquez's team continues mapping expeditions, but progress is slow. Each dive reveals new chambers, new geometric patterns, and new questions about what lies in the unmapped depths below. The cavern system appears to extend far deeper than current submersible technology can reach. Sonar penetration becomes unreliable beyond 12,000 feet, leaving the true extent of these formations unknown. What remains clear is that the seafloor beneath the Bermuda Triangle holds secrets that challenge our understanding of both geology and history. These caverns exist, they follow patterns that seem too precise for nature, and they directly correlate with decades of unexplained phenomena above. Whether they represent unknown natural processes or something else entirely, they've transformed the triangle from maritime folklore into a tangible geological mystery that demands explanation. The deep ocean keeps its secrets well, but these caverns suggest that some mysteries have been hiding in plain sight, waiting beneath the waves for technology capable of revealing their true nature. The silent oceanscape of the Claridge Plateau, 3,000 meters below the Pacific's surface, where sunlight has never touched stone, lies a geological formation that has quietly rewritten our understanding of how life adapts to isolation. The Claridge Plateau stretches across an area roughly the size of Connecticut, yet it remained completely unknown to science until 2019, when deep-sea mapping vessels finally detected this underwater mountain range. They discovered something that shouldn't exist according to everything we thought we knew about deep ocean ecosystems. The plateau sits in what oceanographers call the abyssal zone, a realm of crushing pressure, near-freezing temperatures, and absolute darkness. Here, life typically clusters around hydrothermal vents or survives on the sparse marine snow that drifts down from the surface world above. The Claridge Plateau has neither. No thermal vents, no significant food sources from above. By all scientific reasoning, it should be a biological desert. Dr. Maria Santos was leading the research vessel Custos Deep when they made their first descent to the plateau's surface in September 2020. The submersible descended through layers of increasingly cold, dark water, its lights carving a small sphere of visibility in the endless black. As they approached the plateau at 2,847 meters, Santos expected to document the sparse, slow-moving life typical of the deep abyssal plains. Instead, they found a silent metropolis. The plateau's surface was covered in structures that, at first glance, appeared almost architectural. Towering formations of what looked like calcified coral rose in organized patterns, creating canyon-like passages between them. But these weren't corals as we understand them. Chemical analysis revealed they were constructed by organisms that had no equivalent in any known taxonomy. The creatures building these formations were unlike anything in the fossil record or in any other ocean ecosystem. Moving through this underwater landscape, the research team documented life forms that seemed to operate on entirely different biological principles. Translucent, ribbon-like organisms moved between the formations in what appeared to be coordinated patterns. They showed no response to the submersible's lights. In fact, they seemed to actively avoid illumination, retreating deeper into the structures whenever the research lights approached. The most unsettling discovery came when the team attempted to collect specimens. Every attempt to capture or sample these organisms resulted in their immediate dissolution. Within seconds of contact with the submersible's collection arm, the creatures would literally dissolve into the surrounding water, leaving no trace behind. It was as if they existed in such a delicate balance with their environment that any outside interference caused them to simply cease. Dr. Santos described the phenomenon in her research notes. We're observing life that exists in what can only be called a state of perfect environmental integration. These organisms appear to be constructed from the same mineral components as the water itself, existing in a phase state we don't have adequate scientific language to describe. The silence of the Claridge Plateau became another mystery entirely. Most deep-sea environments, while appearing quiet to human observation, actually pulse with biological activity detectable by sensitive acoustic equipment. Whale songs echo from miles away, thermal vents create subtle sounds as superheated water meets cold ocean, and the movement of deep-sea creatures creates measurable acoustic signatures. The plateau existed in what Santos termed acoustic isolation. No sounds from the surrounding ocean seemed to penetrate the area. Even more puzzling, the research submersible's sonar readings became erratic within the plateau's boundaries, as if the water itself had different properties than the ocean just a few hundred meters away. When the team reviewed their footage later, they noticed something that hadn't been apparent during the dive. The movements of the ribbon-like organisms followed patterns that seemed to respond to the submersible's presence in ways that preceded their actual arrival. Organisms would begin shifting and moving toward areas of the plateau before the submersible reached those locations, as if they were anticipating the visit rather than reacting to it. The implications troubled the research team. These organisms were displaying behavior that suggested either an incredibly sophisticated communication network operating faster than the submersible's movement, or some form of environmental sensing that extended well beyond the organism's physical location. Subsequent expeditions to the plateau have yielded increasingly puzzling results. Return visits to previously mapped areas reveal completely different formations and organism distributions. The plateau's ecosystem appears to be in constant flux, rebuilding itself continuously in patterns that show no correlation to external factors like seasonal changes, ocean currents, or temperature variations. Chemical analysis of water samples from the plateau shows mineral compositions that don't match the surrounding ocean. The water contains elevated levels of rare earth elements and isotopic ratios that oceanographers can't account for. It's as if the plateau exists within its own closed system, operating by rules that don't apply to the rest of the ocean. Perhaps most unsettling is what researchers have begun calling the memory effect. When the team attempted to place permanent monitoring equipment on the plateau, the devices would function normally for several weeks, transmitting data about temperature, pressure, and chemical composition. Then, without warning, the equipment would begin transmitting readings that matched not current conditions, but conditions from previous visits to the same location. The instruments weren't malfunctioning. They were somehow accessing and reporting data from their own past, as if the plateau itself retained some form of environmental memory that the equipment was inadvertently tapping into. Dr. Mintu Santos's team has documented 17 return visits to the Claridge Plateau, each one revealing new aspects of an ecosystem that challenges fundamental assumptions about deep-sea life. The organisms continue to dissolve upon contact, the acoustic isolation persists, and the mineral formations continue their slow, purposeful reconstruction in patterns that suggest an intelligence operating on geological timescales. The plateau sits in international waters, accessible to research teams from multiple countries, yet few institutions have been willing to fund extended studies. The initial findings were met with skepticism from the broader oceanographic community, partly because the evidence remains frustratingly ephemeral. In the deep Pacific, 3,000 meters below a world that never sees sunlight, the Claridge Plateau continues its silent existence, an ecosystem that operates by its own rules, building and rebuilding itself in patterns we can observe but not yet comprehend, populated by organisms that exist in states between the living and the mineral, in waters that remember their own history. Anomalous deep-sea currents. 3 separate oceanographic expeditions, decades apart, discovered the same impossible thing. Deep beneath the Pacific, a massive current flows directly against every law of thermal dynamics we understand. The water moves upward through crushing depths where it should sink, carries Arctic temperatures through tropical zones, and maintains a speed that defies the ocean's natural rhythm. Dr. Elena Vasquez first encountered this anomaly in 2003 while tracking tuna migration patterns off the coast of Chile. Her instruments detected what appeared to be a measurement error, a column of water nearly 2 miles wide, moving at 12 knots in a direction that contradicted every oceanographic model. The temperature readings made even less sense. Water that should have been warming as it rose toward the surface was actually getting colder, as if something deep below was actively cooling it against the natural flow of heat. The phenomenon vanished 3 days later. When Vasquez published her findings, the oceanographic community largely dismissed them as equipment malfunction. Deep-sea currents don't behave that way. They follow predictable patterns driven by temperature gradients, salinity differences, and the Earth's rotation. What Vasquez described violated fundamental principles of fluid dynamics. But then Dr. James Kowalski found it again. In 2011, using completely different equipment in the same general area, Kowalski's team detected an identical current. The dimensions matched Vasquez's measurements almost exactly. A 2-mile-wide column of impossibly cold water flowing upward at 12 knots. This time, they managed to track it for 8 days before it disappeared. Kowalski's instruments recorded something else that deepened the mystery. The current wasn't just moving against natural patterns, it was moving in a perfect spiral, like a massive underwater tornado spinning in slow motion. The water samples they collected told an even stranger story. The current contained microscopic organisms that shouldn't exist at those depths, mixed with mineral compositions that suggested the water had originated from ocean trenches thousands of miles away. Carbon dating revealed something that made no sense. Some of the organic matter in the current was significantly older than the surrounding water, as if it had been preserved in some deep, isolated reservoir for decades. By 2018, a third team led by Dr. Sarah Chen had developed new sonar technology specifically to hunt for these phantom currents. What they discovered changed everything. The anomalous current wasn't an isolated phenomenon. It was part of a vast underwater network, a hidden circulation system operating completely independent of Earth's documented ocean currents. Chen's sonar revealed massive underwater channels carved into the ocean floor, connecting distant basins through passages that don't appear on any geological survey. These channels carried currents that moved according to their own mysterious logic, transporting water across impossible distances while maintaining temperatures and pressures that defied explanation. The network stretched from the Arctic to the Antarctic, with major junction points in the deepest trenches of every ocean. The most unsettling discovery came when Chen's team realized the currents were responding to external forces they couldn't identify. The flow patterns changed with mathematical precision every 47 days, accelerating and decelerating in synchronized movements across the entire network. Whatever was driving this system operated on a schedule that had nothing to do with tides, seasons, or any known astronomical cycle. Dr. Marcus Webb, a theoretical oceanographer at Woods Hole, proposed a theory that challenged basic assumptions about ocean circulation. He suggested that these anomalous currents might be powered by geothermal activity from deep within the Earth's mantle, not just ordinary underwater volcanic vents, but massive convection systems that tap into the planet's core heat in ways we don't understand. Webb's calculations indicated that such a system could indeed create the impossible temperature gradients and flow patterns observed in the phantom currents. But Webb's theory raised more questions than it answered. If these currents were powered by deep geothermal activity, they represented energy sources of staggering magnitude operating completely unknown to surface science. The implications for ocean ecology, climate systems, and our understanding of planetary dynamics would be profound. Independent verification came from an unexpected source. Marine biologists studying whale migration patterns discovered that several species of deep-diving whales consistently altered their routes to follow invisible pathways through the ocean. When researchers overlaid these whale migration data with the phantom current measurements, the correlation was undeniable. The whales weren't just following food sources, they were riding currents that human science had only recently detected. The biological evidence added another layer to the mystery. Marine life obviously knew about these currents, and had been using them for generations. Genetic analysis of certain deep-sea fish populations revealed migration patterns that only made sense if the animals had access to rapid transit routes across ocean basins. Routes that, according to official oceanographic maps, didn't exist. Dr. Chen's most recent expedition in 2022 deployed a new generation of autonomous underwater vehicles designed to follow the phantom currents wherever they led. The results were both fascinating and disturbing. The AVs traced the currents to their source points, massive underwater cavern systems that extended far deeper into the ocean floor than previous surveys had indicated. These caverns appeared to be natural, but their formation defied conventional geological explanation. The water emerging from these deep caverns carried chemical signatures that suggested contact with rock formations that shouldn't exist at those depths. Mineral compositions indicated interaction with materials typically found in the Earth's upper mantle, implying that these current systems somehow connect surface waters with geological processes occurring dozens of miles beneath the ocean floor. Perhaps most intriguingly, the phantom currents appear to be ancient. Geological evidence suggests they've operated continuously for thousands of years, creating their own ecosystem of adapted marine life, while remaining invisible to human observation until sophisticated detection equipment finally revealed their presence. The few scientists studying this phenomenon acknowledge they're examining something that challenges fundamental assumptions about how our planet works. These aren't just unusual water movements. They're evidence of hidden systems operating according to principles we don't understand, driven by forces we haven't identified, connecting parts of our world in ways that exist completely outside established science. Deep beneath the familiar surface of our oceans flows a secret circulation system, ancient and persistent, carrying messages written in water that we're only beginning to learn how to read. Signal Hill of the Unknown. Deep beneath the Pacific, where the ocean floor stretches into absolute darkness, there exists a place that shouldn't exist according to everything we know about marine geology. Ships passing overhead have recorded compass needles spinning wildly, their navigation equipment failing without explanation. Scientists call it Signal Hill, though no hill rises from these depths, only questions that grow deeper the more we investigate. The anomaly was first documented in 1987, when a routine geological survey vessel, the Meridian Explorer *, lost all electronic navigation while crossing coordinates that would later become infamous among oceanographers. Captain Elena Vasquez reported that their compass began rotating counterclockwise in steady, measured revolutions, as if responding to some invisible conductor directing an underwater symphony. The ship's sonar painted images that made no geological sense, geometric patterns etched into the seafloor with mathematical precision that nature rarely achieves. Dr. Bantur-Deliz Wistit-Teen, Lock-Speaking Hobel Tham, Michael Thornton, the marine geologist aboard that expedition, described the readings as impossible architecture, written in magnetism. His team's magnetometer, designed to detect subtle variations in the Earth's magnetic field, registered fluctuations so extreme they initially assumed equipment malfunction. But when backup instruments confirmed the readings, they faced a troubling reality. Something 2 miles beneath the surface was generating magnetic signatures powerful enough to affect instruments far above. The data they collected would remain classified by maritime authorities for nearly a decade, released only after persistent freedom of information requests from independent researchers. What those documents revealed challenged fundamental assumptions about deep-sea geology and raised questions that mainstream science still struggles to address. Follow-up expeditions in the 1990s mapped the anomaly's boundaries with surgical precision. The affected area forms a perfect spiral, stretching across 12 square miles of ocean floor, with magnetic intensity increasing toward the center in mathematically predictable increments. Dr. Sarah Chen's 1994 deep-sea imaging revealed structures that defied classification, corridors of metallic composition arranged in patterns that suggested deliberate construction rather than natural formation. The metallurgy is unlike anything in our databases, Dr. Chen reported to the International Oceanographic Commission. The materials contain isotopic ratios that don't match Earth's known geological processes. We're looking at elements arranged in configurations that shouldn't exist naturally, yet there they are, embedded in rock formations that predate human civilization by millions of years. The mystery deepened when researchers discovered that the magnetic anomalies pulse in regular intervals, every 47 minutes and 36 seconds, a timing so precise it initially led investigators to suspect artificial origin. These pulses generate electromagnetic signatures detectable by satellites, creating brief but measurable distortions in GPS accuracy across a radius of 300 miles. Marine biologist Dr. James Rothwell noticed something equally puzzling about the local ecosystem. Deep-sea creatures in the Signal Hill area exhibit behaviors documented nowhere else in Earth's oceans. Bioluminescent organisms flash in synchronized patterns that mirror the magnetic pulse timing, as if responding to signals human instruments can barely detect. Giant tube worms grow in spiral formations that match the anomaly's geometric structure, their calcium carbonate shells containing trace minerals found nowhere else in marine biology. These organisms aren't just adapting to their environment, Dr. Rothwell explained in his 2003 research paper. They're integrating with it in ways that suggest communication at frequencies we don't understand. The symbiosis between these creatures and whatever generates the magnetic field appears to have developed over geological timescales. The most compelling evidence came from acoustic analysis performed by the Navy's deep-sea monitoring station. Hydrophones positioned around Signal Hill record sounds that oceanographers classify as structured noise, audio patterns too complex for random ocean currents, yet too regular for known marine life. Computer analysis reveals mathematical relationships within these sounds, suggesting they carry information in ways human technology has yet to decode. Dr. Amanda Foster, whose career has focused on underwater archaeology, represents a growing faction of researchers who believe Signal Hill's anomalies indicate artificial origin. Her controversial 2018 study compared magnetic field patterns from the site with similar readings from known ancient structures worldwide, finding correlations that suggest advanced understanding of electromagnetic manipulation. We're seeing evidence of technology that predates our current civilization by orders of magnitude, Dr. Foster argued before the International Archaeological Congress. The precision of these magnetic patterns requires mathematical knowledge that humanity supposedly developed only within the last few centuries. Either our timeline of technological development is fundamentally wrong, or we're looking at remnants of a culture whose capabilities exceeded our own. The implications of Dr. Foster's research have sparked intense debate within scientific communities. Mainstream geology maintains that Signal Hill's anomalies result from unique mineral deposits and underwater volcanic activity, explanations that account for magnetic irregularities without requiring revolutionary revisions to accepted history. However, these conventional theories struggle to address the geometric precision and electromagnetic complexity that characterize the site. Recent developments have added new dimensions to the mystery. Climate change-induced ocean warming has intensified Signal Hill's magnetic pulses, with frequency increasing by measurable percentages each year. Some researchers theorize that rising temperatures activate dormant systems within the anomaly, while others suggest that changing ocean chemistry interacts with the unknown materials in unprecedented ways. The technological implications cannot be ignored. Several aerospace companies have quietly funded Signal Hill research, seeking to understand electromagnetic principles that could revolutionize navigation and propulsion systems. The material science alone, metallic compositions that generate sustained magnetic fields without external power sources, represents potential breakthroughs in energy technology. Yet Signal Hill guards its secrets behind barriers of depth, pressure, and mystery that human technology can only begin to penetrate. Each expedition reveals new questions while answering few existing ones, creating a puzzle that grows more complex with every piece of evidence gathered. The ocean above continues its eternal rhythms, waves rolling across a surface that betrays nothing of the magnetic symphony playing in the depths below. Ships still report compass anomalies when crossing these coordinates, their instruments spinning to music only the deep sea can hear. And far beneath, where sunlight has never reached, something continues pulsing with the precision of a heartbeat, keeping time with secrets that may be older than human memory itself. Luminescent oceans on other worlds. When NASA's Galileo spacecraft transmitted its first detailed images of Europa in 1979, scientists noticed something that made them pause. Beneath the moon's icy crust, thermal readings suggested an ocean twice the volume of all Earth's seas combined. But it wasn't just the presence of water that captured their attention. It was the possibility that this distant ocean might glow. Dr. Rebecca Martinez has spent the last decade studying bioluminescence in Earth's deepest trenches. Her research takes her to places where sunlight has never touched, where creatures generate their own ethereal light through chemical reactions perfected over millions of years. In 2019, while analyzing samples from a dive near the Mariana Trench, she made a connection that bridges our world with others scattered across the cosmos. "I was looking at this tiny amphipod under the microscope," Martinez recalls. "It was producing this blue-green light using luciferase enzymes, the same basic chemistry we see in fireflies, but this creature had evolved in complete darkness, in crushing pressure, feeding on chemical energy from hydrothermal vents. That's when I realized, if life can create light in Earth's most extreme environments, what might be glowing in Europa's hidden seas? The question matters more than academic curiosity might suggest. Every organism that produces bioluminescence on Earth does so for survival. Deep-sea anglerfish dangle luminous lures to attract prey. Jellyfish flash brilliant displays to confuse predators. Bacteria colonies create living constellations on the ocean floor, communicating through patterns of light that pulse like Morse code through the darkness. These aren't random evolutionary accidents. They're sophisticated responses to environments that mirror conditions scientists expect to find beneath Europa's ice, and potentially within the subsurface oceans of Enceladus, Titan, and a dozen other worlds we're only beginning to understand. Consider what we know about Europa's buried sea. The Moon orbits Jupiter in a gravitational dance that flexes its interior, generating heat through tidal friction. This process creates the same type of hydrothermal activity that supports thriving ecosystems around Earth's deep-sea vents. The chemistry is remarkably similar: sulfur compounds, hydrogen sulfide, and metallic minerals dissolved in liquid water under immense pressure. On Earth, these conditions have given rise to some of our planet's most spectacular light shows. The Atolla jellyfish creates what marine biologists call a burglar alarm, a spinning wheel of light that can be seen from hundreds of meters away. The vampire squid transforms its entire body into a bioluminescent constellation when threatened, ejecting clouds of glowing mucus that hang in the water like fallen stars. But perhaps the most intriguing parallel lies in Earth's bacterial communities. In the deepest parts of our oceans, where the pressure exceeds 1,000 times what we experience at sea level, bacterial colonies have developed collective bioluminescence. They pulse in synchronized patterns, creating vast networks of living light that can span kilometers of seafloor. Some researchers believe these bacterial communities represent a form of distributed intelligence, a biological internet operating in the planet's most isolated spaces. Drs. Kevin Nordstrom, an astrobiologist at the University of Washington, has been modeling how similar communities might function in Europa's ocean. His calculations suggest that any ecosystem complex enough to support multicellular life would likely develop bioluminescence as a primary survival strategy. You have to remember that Europa's ocean has existed for potentially billions of years, Nordstrom explains. That's enough time for evolution to explore every possible niche, every survival strategy. On Earth, bioluminescence evolved independently at least 40 different times. In an environment where darkness is absolute and permanent, we should expect it to be even more prevalent. The implications extend beyond simple biological curiosity. If Europa's oceans contain bioluminescent life, that life might be detectable from the surface. Ice-penetrating radar already suggests that Europa's crust contains channels and caverns where the ocean occasionally reaches toward space. During the Moon's rare moments when these chambers align with viewing angles from Earth, sensitive instruments might catch traces of biological light filtering through kilometers of ice. NASA's upcoming Europa Clipper mission, scheduled to launch in 2024, will carry spectrometers capable of detecting exactly these kinds of faint biological signatures. The spacecraft will make nearly 50 close passes of the Moon, mapping its surface and analyzing the chemical composition of water plumes that occasionally erupt from Europa's south pole. But the search for luminescent seas reaches beyond Europa. Saturn's moon Enceladus displays similar characteristics: an underground ocean, hydrothermal activity, and organic compounds detected in its ice geysers. Titan, with its methane lakes and complex organic chemistry, might harbor forms of bioluminescence, based on entirely different biochemical pathways than anything we've discovered on Earth. Recent advances in deep-sea exploration have revealed that Earth's bioluminescent organisms are far more diverse and widespread than previously imagined. In 2021, researchers from the Woods Hole Oceanographic Institution discovered bacterial communities producing light at depths previously thought impossible for biological activity. These organisms thrive in conditions that closely approximate what we might find in the deepest portions of Europa's sea. The discovery suggests that bioluminescence isn't just an adaptation to darkness, it's a fundamental property of life, operating at the edges of what's possible. The same chemical processes that allow Earth's deep-sea creatures to generate light from biochemical reactions could be creating underwater auroras in oceans we've never seen, around worlds we're only beginning to explore. As our instruments become more sensitive and our understanding of extreme life deepens, we edge closer to answering whether Earth's glowing seas offer a preview of what awaits beneath the ice of distant moons. The creatures living in our planet's deepest, darkest waters might be the key to recognizing life in the most unlikely places, life that announces its presence through patterns of light that have been pulsing in hidden oceans for eons, waiting for us to develop the technology and wisdom to notice their distant signals. Culture of the coelacanth. On December 22, 1938, Marjorie Courtenay Latimer received a phone call that would rewrite textbooks. The young curator at the East London Museum in South Africa had developed a friendship with local fishermen who would occasionally bring her unusual specimens from their nets. That morning, Captain Hendrik Goosen had something different, something that made Marjorie's hands tremble as she lifted it from the boat deck. The fish was enormous, nearly 5 feet long, with scales that caught the light like armor. Its fins were unlike anything she'd seen before, thick and lobed, almost like primitive legs. Most unsettling were its eyes, which seemed to hold an ancient intelligence, as if they had witnessed the birth of continents. Marjorie knew immediately she was looking at something extraordinary. What she didn't know was that she was staring at a ghost, a creature science had declared extinct for over 65 million years. The coelacanth, pronounced coelacanth, was supposed to be fossil record only. Museums worldwide displayed their petrified remains alongside trilobites and ammonites, remnants of a world that vanished when the dinosaurs died. Every textbook stated the same facts. Coelacanths were transitional creatures, evolutionary stepping stones between fish and land animals, extinct since the end of the Cretaceous period. But here was one breathing in Marjorie's hands. Or rather, it had been breathing until the fishermen hauled it into our world of thin air and blazing sunlight. Unable to preserve the specimen properly, Marjorie made detailed sketches and took photographs before having it mounted by a local taxidermist. Then she did something that would echo through the halls of science for decades. She sent a letter to Professor J.L.B. Smith, South Africa's leading ichthyologist, along with a rough sketch of the creature. Smith's response was immediate and urgent. He caught the first train to East London, his mind racing with possibilities he barely dared consider. When he arrived at the museum and saw the mounted specimen, his legs nearly gave out. Later, he would write that he felt like he'd been struck by lightning, and that his whole life had changed in an instant. This was no ordinary fish. This was a living coelacanth, a creature that had supposedly vanished from Earth before mammals walked upright, before flowers bloomed, before the continents took their modern shape. Smith named the specimen Latimeria columnae, honoring both Marjorie Courtenay Latimer and the Columna River where it was caught. But one specimen, however extraordinary, couldn't answer the thousands of questions now flooding the scientific community. Was this a lone survivor, a remnant population, or something else entirely? For 14 years, Smith searched obsessively for another coelacanth. He distributed thousands of leaflets throughout the western Indian Ocean, offering substantial rewards for intact specimens. The scientific world watched and waited, some beginning to wonder if the first discovery had been a fluke, perhaps an exceptionally well-preserved ancient specimen somehow churned up from deep sediments. Then, in 1952, a telegram arrived that would vindicate Smith's unwavering faith. Have coelacanth, dead, frozen. Reply immediately. The message came from the Comoro Islands, a volcanic archipelago between Madagascar and mainland Africa. Local fishermen there had been catching these creatures for generations, calling them gumbessa. To them, the coelacanth wasn't extinct, it was dinner, though a tough and oily one they generally avoided. This revelation stunned the scientific community. Not only had coelacanths survived the mass extinction that claimed the dinosaurs, but they had been living virtually unchanged for hundreds of millions of years. The very fish that Charles Darwin might have predicted as a transitional form between sea and land had been quietly thriving in the deep waters of the Indian Ocean, while the world above transformed beyond recognition. But the coelacanth's secrets ran deeper than mere survival. When researchers began studying living specimens, they discovered anatomy that challenged basic assumptions about evolution and extinction. The creature's fins contained bone structures remarkably similar to the limbs of four-legged animals. Its notochord, a primitive spinal structure, had remained unchanged since the Devonian period. Most remarkably, the coelacanth possessed a unique joint in its skull that allowed the front portion to swing upward when feeding, a feature unknown in any other living animal. Even more intriguing was the coelacanth's reproductive strategy. Unlike most fish, coelacanths give birth to live young after a gestation period that scientists believe may last over a year, possibly even 5 years. The young emerge as miniature versions of their parents, already equipped with the same ancient architecture that has served their lineage for eons. In 1987, marine biologist Hans Fricke achieved what many thought impossible. He filmed living coelacanths in their natural habitat. Using the submersible GEO, Fricke descended to depths of 200 meters off the Comoro Islands. What he witnessed challenged yet another assumption about these creatures. Rather than the sluggish, primitive swimmers scientists expected, coelacanths moved with surprising grace and purpose. They swam in small groups, their lobed fins providing precise control in the volcanic caves and coral overhangs they called home. Most remarkably, Fricke observed them displaying complex behaviors, coordinated group movements, apparent communication, and sophisticated hunting strategies. The coelacanth's brain, initially dismissed as primitive, revealed unexpected complexity. Researchers discovered that while the brain itself was small, the creature possessed an electrosensory system that allowed it to detect the electrical fields generated by other living organisms. This ancient fish was equipped with sensory capabilities that seemed almost supernatural. In 1998, the coelacanth world expanded again when researchers discovered a second species in Indonesian waters, Latimeria menadoensis. This finding suggested that coelacanths might once have had a much wider distribution, with populations surviving in deep water refuges across the Indo-Pacific. Today we know that coelacanths live in underwater caves and steep volcanic slopes, emerging at night to hunt in the perpetual twilight of the deep. They can live for decades, possibly over a century, growing slowly in their cold, dark world. Their population numbers remain uncertain, but estimates suggest fewer than 1,000 individuals survive in the wild. The coelacanth story continues to unfold in ways that surprise researchers. Recent genetic studies suggest these creatures may hold keys to understanding not just the transition from sea to land, but the very nature of evolutionary time itself. They are living laboratories, carrying within their cells the genetic memory of a world we can barely imagine. Each new discovery about coelacanths raises more questions than it answers. How did they survive multiple mass extinctions? What other extinct creatures might still inhabit the deep ocean? And what secrets do their ancient genes hold about the fundamentals of life itself? In the deep waters off volcanic islands, where light fades to memory and pressure would crush surface dwellers, coelacanths continue their ancient existence, guardians of mysteries we're only beginning to comprehend. The phenomena of milky seas. For centuries, maritime logs have recorded encounters that sound more like fiction than fact. Ships crossing vast stretches of ocean suddenly find themselves sailing through what appears to be liquid starlight, miles upon miles of seawater glowing with an ethereal, milky luminescence that stretches beyond every horizon. These aren't isolated incidents. The phenomenon has earned its own designation in oceanographic literature, milky seas, and while science has begun to piece together explanations, the sheer scale and mystery of these glowing waters continues to confound researchers who study the deep. The HMS Bulwark, documented one of the most detailed early encounters in 1875. The captain's log describes how the ship appeared to be sailing through a sea of milk for hours, with the glow so intense it illuminated the vessel's rigging and cast shadows on deck. Crew members reported being able to read by the ocean's light alone. What makes these accounts particularly compelling is their consistency across different eras and ocean basins. Dutch explorers in the 17th century described identical phenomena. Modern satellite imagery has captured the same ghostly patches of luminescence from space, vast areas of ocean glowing like fallen clouds against the dark water. The leading scientific explanation centers on bioluminescent bacteria, specifically a species called Vibrio harvii. Under certain conditions, these microscopic organisms can bloom in astronomical numbers, creating bacterial mats that span hundreds of square miles. When disturbed by wave action or passing ships, they emit light through a process called quorum sensing. Essentially, they communicate through chemistry and coordinate their glow. But this explanation, while logical, raises its own questions. The energy requirements for sustaining such massive displays seem almost impossible. These bacterial colonies would need to consume enormous quantities of organic matter to fuel their light production across such vast areas. Where does all that energy come from in the nutrient-poor open ocean? Dr. Stephen Miller, who has spent decades studying bioluminescence, captured satellite images of milky seas from the DMSP satellite in 2005. The glowing patch he documented near Somalia covered an area larger than Connecticut, a single organism colony spanning over 6,000 square miles. The bacterial density required to produce visible light at that scale challenges our understanding of marine ecosystems. The timing of these events adds another layer of mystery. Milky seas don't appear randomly. They seem to coincide with specific oceanographic conditions, particular temperatures, currents, and seasonal patterns that scientists are still working to decode. Some researchers suggest the phenomenon might be linked to El Niño cycles or deep ocean upwelling events that bring nutrients from the abyssal depths. What's particularly fascinating is how the glow behaves. Unlike other forms of marine bioluminescence that flash or pulse in response to disturbance, milky seas maintain a steady, continuous luminescence. Sailors describe the light as having an almost supernatural quality, not the blue-green flash of disturbed plankton, but a softer, white radiance that seems to emanate from the water itself. Historical accounts suggest these phenomena might be more common than modern records indicate. Ancient Polynesian navigators had specific terms for glowing seas in their oral traditions. Arabic maritime texts from the medieval period describe similar encounters in the Indian Ocean. The consistency of these descriptions across cultures that had no contact with each other adds weight to the reality of the phenomenon. Recent research has revealed that milky seas might serve an ecological purpose beyond our current understanding. Some marine biologists theorize that these massive bacterial blooms could be oceanic communication networks, vast colonies of microorganisms coordinating behavior across hundreds of miles of ocean. The implications of such coordination would fundamentally change how we view marine ecosystems. The bacterial species responsible, Vibrio harvii, exhibits behaviors that seem almost intelligence-like. Individual cells can detect the density of their population and adjust their light production accordingly. They appear to make collective decisions about when to bloom and when to die back. This level of coordination in such simple organisms challenges traditional concepts of marine life organization. Temperature plays a crucial role, but not in the way you might expect. Milky seas typically occur in tropical and subtropical waters, where temperatures remain relatively stable. However, satellite data shows they often coincide with subtle temperature anomalies, small variations that suggest complex interactions between surface water and deeper ocean layers. The nutrient paradox remains one of the most intriguing aspects of milky seas. These massive bacterial blooms occur in some of the most nutrient-poor waters on Earth, the open ocean deserts where life typically struggles to survive. Yet somehow, billions of bacteria find enough sustenance to create displays visible from space. Some researchers propose that the bacteria might be tapping into nutrient sources we haven't identified, possibly organic matter from deep ocean currents, or even atmospheric nitrogen fixation. Modern technology has allowed scientists to study Milky Seas in ways impossible for earlier researchers. Spectral analysis of the light reveals specific wavelengths that provide clues about the organisms involved. Autonomous underwater vehicles can now sample these glowing waters directly, collecting bacterial specimens and measuring chemical conditions in real time. Yet for all our technological advancement, witnessing Milky Seas remains largely a matter of chance. The phenomenon occurs unpredictably across vast stretches of ocean, often in remote areas far from research vessels. Most of what we know still comes from satellite imagery and the scattered reports of commercial ships whose crews happen to encounter these glowing waters. The psychological impact on those who witness Milky Seas shouldn't be underestimated. Sailors describe a profound sense of otherworldliness, of sailing through liquid starlight in a universe where the normal rules seem suspended. These accounts consistently mention the absolute silence that accompanies the phenomenon, as if the glowing sea has created its own hushed cathedral of light. Perhaps most mysteriously, some bacterial samples collected from Milky Seas have shown genetic variations not found in laboratory cultures of the same species. The extreme conditions required to create such massive blooms might be driving rapid evolutionary changes, creating new variants of these organisms that exist only during these rare oceanic events. The relationship between Milky Seas and climate patterns continues to puzzle researchers. Some data suggests these phenomena might be increasing in frequency, possibly linked to changing ocean temperatures and current patterns. If true, Milky Seas could serve as indicators of larger oceanic changes we're only beginning to understand. As our instruments grow more sophisticated and our monitoring networks expand, we're likely on the verge of new discoveries about these luminescent waters. But for now, Milky Seas remain one of the ocean's most beautiful mysteries, a reminder that even